In this course, I'll teach you how to handle your data more efficiently using Power BI. I'll show you the ins and outs of Power BI using the ETL or Extract, Transform, Load framework. By the end of this course, you'll feel comfortable importing and transforming data from many different kinds of data sources. Then you can blend and join this data together for further analysis. So what are you waiting for? Let's get started transforming and automating your data processes with Power BI. Microsoft officially debuted Power BI in 2015, but its origins date several decades farther back. They debuted Access in 1988 and Excel a few years after that. And there are also newer components like Power Pivot and Power Query, which grew from expanding the needs of Excel, a tool that remains a mainstay of data modeling and analysis. In the last few years, we see a surge in data volume and speed, as well as an increased demand to understand and analyze trends from this data. Power BI allows us to scale up to this demand by creating models and reports that cater to business users and decision makers. We can separate Power BI capabilities into 3 levels. First, we can monitor data trends. Second, we can analyze these data trend results to understand their impact to the business or organization. Third, we can make decisions and forecast future trends based on this data analysis. On a high level, we break down the Power BI process into 3 smaller sub-processes. First of all, we import the raw data from existing sources. Then, we create transformations and calculations to make usable data sets. Lastly, we design visuals to see trends and relationships. In this course, we will learn an important but not exhaustive view of Power BI data methods by focusing on the first 2 process steps. Power BI has the capability to easily share dashboards, models, and reports in a controlled and scalable environment. In this course, we are going to focus on using Power BI Desktop as the recommended mode for developing and designing dashboards. We can then upload these dashboards to shared cloud services such as Power BI Pro, Premium, Report Server, Embedded, or Mobile. ETL. You've probably heard of it before, but what does it stand for exactly? Well, it's an acronym. ETL stands for Extract, Transform, Load, and it's a must-know framework for data methods. The extract step refers to the process of pulling or extracting raw data from its original data source. We set up a connection for each data source we want to use by leveraging an array of data connector options such as Excel, Azure, Microsoft Flow, databases, or web data. Microsoft denotes a connector with a suffix beta if they are still developing it for large-scale use. We can divide the transformation step into 3 distinctive smaller processes. Data cleaning, which includes filtering rows, splitting columns, changing data types, and formatting. Data integration, which includes adding lookup keys, joining tables, and aggregating data. And data enrichment, which includes creating calculated columns and dynamic tables. In the final ETL step, we load the shaped and transformed data tables into the Power BI interface. From there, we can leverage capabilities such as creating DAX measures and data visualizations. When we refresh a data table, it refreshes not only the data extraction steps, but also all the transformation steps, thus making it an automated process. The entire ETL process does not and cannot change or affect anything in the original data source because we are essentially making a copy of the data to import. When decreasing performance becomes an issue, we can analyze the query to determine the source of the slowing performance and decide what changes to make. However, we need to make sure the query works accurately first and then work on improving the query performance. Power BI has one of the most powerful semantic layers in its class, which allows for many data shaping and calculation options. Power BI Desktop works as a composite model because it supports multiple data connections and sources. We can efficiently connect to data tables from multiple sources, such as both SQL Server and Excel files, in a single application, which we can then use for analysis. Let's focus on one aspect of the semantic layer, and that is the capabilities of the Power Query editor, where the majority of the ETL process occurs. This query editor records both the data extraction and transformation steps for data connections. For those familiar with Excel VBA macros, the Power Query editor similarly allows us to automate a repeated process for refreshing and updating data, which saves having to repeat an entire process manually and limits the opportunities for potential errors. We can easily transfer much of the material in this course to Power Query in Excel, allowing us to leverage this knowledge across multiple Microsoft products. Even using Power Query, Excel still has limitations in terms of size and performance for loading data and creating stable calculations. I would recommend giving tables sensible names such as Santa Barbara weather, rather than what we may see as the default query name. Many users who do not work in technical development roles can develop dashboards in Power BI, and using sensible table names, we can make working with the data easier and less intimidating for them. We can set up multiple data connections within the Power Query editor, including data tables, lookup keys, and exception tables. Here, we can connect the data table to the lookup key on the unique ID to link the region information to each country. This makes it easier to see and change the grouping without having to change the entire data table. Then, if we know we want to exclude France, for example, we create a separate exceptions table to manage whether or not we include it in the dataset by essentially filtering it out. Microsoft is investing a great deal into Power BI. Therefore, your Power BI desktop and cloud accounts may not look the same as mine because they push application updates out once a month to improve features and capabilities of the tool. If you can access the exercise files, you can follow along on your own computer. Just start with the begin state file in each video folder. However, you will need to change the file paths to your own computer so you can open them up. When you open up the file, go to Edit Queries, double-click on the source step in the Applied Steps list, and browse for the appropriate file path and select the file. Hit Open and OK. And there we see we've updated the folder path and the file path so that we can follow along with the video. We also connect to a database where we uploaded the CDC weekly flu numbers. I think that you can learn a lot by watching and learning, but if you would like to recreate SQL Server access in Power BI, you can download the ILI.net flu dataset and upload and connect to your own database. One of the risks of connecting to online data is that the source could move or update out of our control. Therefore, some of the URL links may change, and you will need to make sure to point to the updated web location. We first look at how to connect to static files. Unlike Excel files, text files store unlimited rows of data, but do not store formatting or calculations. The commonly used CSV files use commas to separate the fields for each data record or row. DSV files use other separators such as tabs or colons. Fixed-width text files use a fixed number of characters allocated to each field to separate the fields rather than an actual separator. Let's see how we can import a CSV file into Power BI. We download the CSV file of weekly flu mortality numbers from the CDC website we see here. In the flu view, let's go ahead and download the data. We select the data source as ILI.net, click on National for the radio button, and then let's also select the past 3 seasons for the flu data. Go ahead and click Download Data. You'll also find a copy of this CSV in the exercise files. Now that you've downloaded the data, go ahead and open up Power BI. When we open up Power BI, we click on Get Data on the splash screen. We set up the text CSV connector to the file we just downloaded. Go ahead and click on this CSV file. And rather than loading, we just go ahead and hit Transform Data. Now we see here the data table from the CDC flu mortality numbers. When we look over here to the applied steps on the right-hand side, notice that we have a source step and a change type step. The gear wheel indicates that we can edit this existing step, so we go ahead and double-click on the source step. We see the path. We also see that it opens as a CSV document and uses a comma as a delimiter. Go ahead and click OK. Now we rename this query CSV CDC flu data. Now I'm going to go ahead and save this Power BI file. So I go to File, Save As. So now in this message, go ahead and apply later and save this file as CDC flu data. Great, we've just imported our first CSV. We also have the option to manually enter values by typing or pasting them directly into a new data table. We may find this method helpful when we are getting data from a source difficult to directly extract data from or an unstructured source. In Power BI, the easiest way to manually enter data is to first exit out of this splash screen, and then we can edit the queries by hitting the Edit Queries button at the top of the home screen. This takes us back into the query editor. We can go ahead and enter data right up here at the top. In this dialog box, we are going to enter the data to create this table manually. In column 1, we're going to call this time period. I'm going to enter in months 1 through 10. Then we add the amounts for each of these months. Now we can rename this query by calling it sample set down here at the name box at the bottom. I'm going to go ahead and call it sample data. Hit OK. Now we save this file as manual sample. Select to apply later. Manual sample. And hit save. And there we have it. When setting up an Excel connection, we first need to select the file location, and second, we need to select the tables or tabs to use within this Excel file. We get an Excel file that maps US GeoIDs to areas such as counties from the website we see here on the screen. Download the All Geocodes file. You can find this file in the folder 0103 of the exercise files if you don't feel like downloading it from the website. We open up the file to inspect the formatting and the tabs within it. Notice that we only see one single tab of data with several rows above the headers. Notice that for now we do not see the GeoID field, but we will create it later. When we open up Power BI, we click on Get Data on the splash screen. Now we select the Excel connector and point to our Excel file. We hit Open. We can preview tables in this file, and we see two options in our navigator window. If we click on the first option, we see that the formatting looks a lot like the formatting of the Excel file that we looked at earlier. Notice the headers and the rows on top before we get to the data table. Next, click on the option below. We see this looks very much like the previous selection. However, we do not see any of the additional rows on top. Power BI is using AI to take the labels off the top rows in the table, so we do not have to do so ourselves. Let's load this option by clicking on the button next to it. So we see the check mark show up. We click on Transform Data. Now we can go ahead and edit this query. We first rename this GeoID to County Mapping. And because we are going to revisit another connection option later, we're going to also call this Excel Manual File. And hit Enter to rename it. Renaming the query to a name like this makes it easier to read so that other users can pick it up and work with it later as well. Notice now in the applied steps on the right-hand side of the screen, we see a source step and a navigator step, which is where we select the tables, and we also see two other steps for promoting headers and changing data types. Now we save this file as US Census. Select to apply the changes later. Hit save. Again, the final version of this file is in the 0103 folder of the exercise files. Great! We've just connected to our first Excel file. PDF files format reports and data sets in an easy-to-read and share format, but this very formatting can make it difficult to extract data from them. Let's obtain weather data for the LinkedIn Learning Studios just outside Santa Barbara, California, from the NOAA CDO web portal. Here we select the weather observation type as a daily summary, which will provide precipitation and temperature information. We select the date range that's already in the box. Next, we go ahead and make sure that we search for stations, and now we're going to go ahead and just type in Santa Barbara. When we hit search, we go to another screen. Let's just go ahead and select this first airport option, which we add to the cart. We then go to the cart and view the items. We select the format output as PDF. We already see the date range and the airport in Santa Barbara that we want to select to. Continue. Then we enter our email addresses to receive the report at. You will then receive an email notification to access your own PDF file link. You can access this file in the 0104 exercise folders. Microsoft recently developed a direct Power BI PDF connector. On the flash screen, select Get Data. We select to connect to the PDF. We choose the NOAA Santa Barbara weather PDF that you can also access in your own exercise files. And we hit Open. Here we see a list of the tables in the PDF file. We do not have to connect to all these tables, and we'll talk more later about how we can connect to them using another technique. For now, we are just going to connect to the table 002, page 1. We see some of the data set here on the screen. We click on Transform Data. I know that I highly recommend changing the names of the queries, but this particular PDF file is something we're using to test out how the PDF connector works. We're going to explore another method using a folder of PDFs to better access the files. So that being said, I'm just going to leave the query, the default query that we found it. We save this file as NOAA PDF. And this gives us an initial look into how the PDF connector works. Receiving the same file every month in the same file type, we could spend our time importing them separately, or we could expedite the process by putting them in the same folder. When we add a new file to the folder, we just have to refresh the query. Using a folder as a data connection means that we also import all the subfolders within the folder. This method works best when the format of the files to combine in the dataset have the same columns and formatting. We use the same initial process to set up the folder connection for all file types, but the transformation process to create a combined dataset differs by file type. Now let's go back to the same NOAA weather portal we used to download the PDF file, except this time we will choose to receive it in the CSV format. Again, we select Daily Summaries for 2019, and we search for Santa Barbara again. We select the airport and add that to the cart. Let's select to receive the file as a CSV format. We choose the date range for the current year, view the items in the cart. Now in the station detail and data flag options, choose to select all the options. Conversely, in the select data types, choose to select all the weather types: precipitation, air temperature, wind, and weather type. Select to continue. And here's where we enter our email address to go ahead and submit the order. After we download the weather for Santa Barbara and for Los Angeles for both 2018 and 2019, we go and save them in a NOAA CSV folder. We also convert them into Excel files and save them for 2018 and 2019 weather. In both these Excel files, we can see the Los Angeles and the Santa Barbara weather patterns. You can access these files in your own 0105 exercise files. We also put the PDF in its own standalone folder, which we will cover later how to transform them all as a single query. We start at the Power BI desktop splash screen. We select Get Data. We select the folder connection, and we then copy the path of the folder that we just saw the files in. Let's start by connecting to the NOAA CSV folder. Select the folder and click OK. We click OK again. On the next screen, we see a list of the NOAA CSV files, as well as some metadata about their dates and their folder paths and sources. We do not initially select to combine them, but rather transform the data. We now have a table that shows a row for each file name. The folder path appears last in the columns, and the second column shows the name of the CSV file. The first column is called Content. In the Content column, we can access the files through the binary hyperlink. Later, we will walk through how to transform these 4 separate lines into an entire data set. But for now, we're just going to save this as a NOAA CSV Power BI file. We will apply these queries later, and we hit Save. Now let's set up a connection to the PDF folder and the Excel folder using Power BI again. On the splash screen, again, select Get Data. Select the folder option again. We browse for the particular folder for the PDF and the Excel files. First, we're going to connect to the Excel files. I hit OK. Select to transform the data. Again, we see a connection to the folder with the same table layout that we saw with the CSV files. However, we are going to combine these separately and in a different manner, as we will learn later in the transformation process. We are also going to add the NOAA folder PDF connection to this same file. Again, select Folder. And select the NOAA PDF folder path. Again, hit OK. And select to transform the data. We'll come back to this later. Here we see a query for the NOAA Excel folder and for the NOAA PDF folder. For now, we are going to save this as its own separate file folder. Apply this later, and we are going to call this NOAA Excel and PDF folders. Hit Save. We will work through the file transformation process for both these connections later. Relational databases consist of tables in a data warehouse that typically use SQL for querying and maintaining these databases. We will find it easiest to work with these databases if we at least understand the database configuration to connect to the optimal and correct tables. Relational database connections in Power BI include SQL Server, Oracle, and HANA, among many other options. Multidimensional cubes, OLAP cubes, or SAS models work as predefined queries referencing databases where the user does not write a query to access the data, but rather connects to a model with predefined dimensions and calculations. For example, SQL Server Analysis Services uses MDX queries to create a cube database model instead of getting data from the relational database using SQL commands. If we cannot find the database connector in Power BI, we can check to see if a platform like Microsoft Azure supports it. Azure functions as a cloud computing service supporting software, platforms, and infrastructure as services for both Microsoft products and third-party software and systems. It supports connections for both relational databases and cubes. We can also access databases through an ODBC connection if we can install the vendor's ODBC driver on our own computer. ODBC stands for Open Database Connectivity. It functions as an interface from Microsoft, enabling access to data management systems using SQL. In order to connect to the database, we need our own set of database access credentials, including the server name, the database name, if applicable, and any access credentials. Microsoft systems often use shared Windows credentials across multiple platforms. Note that the database credentials in Power BI Desktop may not transfer between users when you share Power BI files, so make sure other users also have database access credentials if you share it with them. When they open up the file on their computer, they will have to enter their own credentials to refresh the data from the databases. We can also customize configurable connection settings options such as credentials, encryption, privacy levels, and native database queries. In some organizations, the IT group may control the privacy level, and we cannot change it ourselves. The premise behind changing the privacy levels becomes imperative when sharing Power BI files because privacy levels will likely vary across a wide user base. I'm in the CDC Flu Data Power BI file we created earlier by connecting to a CSV connection. I'm going to show how to connect this to a SQL Server and SQL Server Analysis Service model. However, you will unlikely be able to access the database yourself, so just follow along and see how database connections work in Power BI. We select from New Source. First, we're going to select SQL Server. I'm going to enter my server name and enter my database name. Notice the radio button to select between import and direct query. Let's set up our query using import. If we want to get the data using a custom SQL query, we would enter it by expanding the box below. I would recommend testing SQL queries out beforehand to make sure they work in an application like Visual Studio. In this example, we will not use a SQL query, so go ahead and close out this Advanced Options menu and proceed to the next screen by clicking OK. From here, we select the ILI net table we want to use from the database, confirm. Now we see we have our connection to the database table set up in SQL Server. Now I'm going to set up or show how you would access a SQL Server Analysis connection. Again, go to New Source. Let's click More to see more of the options that are available. In Database, Azure, and Other, we see the ODBC, the Azure options, and here in the Database tab, we see the databases. Connect to the SQL Server Analysis Services database. Notice that similarly to connecting to SQL Server, we also see the server and database options available on this screen. We also see two radio button options like we saw in the SQL Server. However, this time it's between Import and Connect Live. If we select the Import option, we will see an area to enter the MDX or DAX query below. We can choose to enter a query here, or if we do not enter a query, we can access tables for the model in screens after that. If we select Connect Live, it will disable the MDX or DAX query, and Power BI will become a front-end connection only. Let's exit out of here, and we see how we would set up these database access connections. Earlier, we saw the following data connection modes for databases: Import, Direct Query, and Live. In the cloud services, we can also leverage the push mode. In the future, Microsoft will continue to develop and improve the connection options available for all these data connection modes. A recent update to Power BI Desktop allows us to connect to both direct query and import in combination for different queries in the same file. We use import as the typical default data connection type. Microsoft recommends this method because it takes advantage of the high-performance query engine and allows for us to leverage the full range of options for working with data. Direct query allows us to connect to data in its original source repository. This option works best when the underlying data provides interactive queries returning data in less than 5 seconds, or if this data changes frequently and we need the latest updates. Power BI supports direct query for several database options, including some of these we see here on the screen. However, check the Microsoft and the Power BI documentation for the latest applicable databases. A live connection allows us to connect many reports or dashboards to one Power BI connection, such as a large-scale BI project like SQL Server Analysis Services. It provides advantages such as creating a centralized approach where developers can secure and control data model access, partitioning the model to process independently and more efficiently, minimizing discrepancies through consolidated calculations and analysis, scaling subscriptions across many users, avoiding memory or size constraints by pushing the intensive work to the database, and streamlining development through lower implementation times. However, it also creates many disadvantages, such as disabling many of the key features and capabilities in Power BI, and it also makes Power BI a front-end process where we cannot add query steps or custom M code, although we can add DAX measures after loading the model. Push mode is a common approach for real-time data seen in Power BI cloud services. It is not a formalized data source per se, but rather data pushed through an external streaming service such as Azure Stream Analytics. Databases, by design, process data efficiently. Query folding optimizes query performance by pushing as much work as possible back to the database connection behind the scenes. In order for this functionality to work, the database we connect to must have a server with query folding capabilities. If the database does not support query folding, we can still extract and transform the data, but it will perform less efficiently. We cannot leverage query folding with an Excel connection because Excel is not a database and therefore has no engine to fold queries. On a high level, SQL logic works by selecting the data table, selecting the columns from this table, and then filtering the columns with conditions. Query folding translates our transformation commands into SQL and sends them back to the database without actually writing any SQL code ourselves. Accessing the native query allows the query to perform more efficiently, even for large data sets. To avoid breaking query folding capabilities, do not use a custom SQL query unless you are a SQL expert, custom M code, or parameters dynamically as filters. While accessing the native query optimizes performance, we also may want to break the query folding capabilities to use the functionalities that enable a great deal of flexibility in the query editor we will see later. Let's go into Power BI. Let's look at our initial relational database connection to SQL Server for the CDC flu mortality numbers, where we see the source and navigation query editor steps on the right. If we right-click on the source step, we see that native query is grayed out, indicating it is not an option. Then, if we right-click on the navigation step, we see the View Native Query option available, meaning that query folding is available at this step. We select View Native Query. Here we see all the columns in the database table. It looks very much like SQL code for those of you familiar with SQL. Let's set up this database connection again and see how it works if we use a custom SQL statement. What we're going to do here is we're just going to set up the connection again, and this time we're going to enter SQL code into the Advanced Options box. We open up the Advanced Options button at the bottom, and we write Select all the columns from the database table and hit OK. We see the query loading. Now we see the same table that we saw earlier, and we just selected a database table using the SQL Server connection. When we right-click on the source step, we see the View Native Query option is not available, meaning that the SQL code that we used did indeed break the query folding capabilities. We have access to vast online libraries of free public data. We can download this data manually, but web connections eliminate the potential for manual errors and allow us to easily refresh data sources. Tread carefully, though, because we do not have direct control over even established external data sources, which could move, delete, or change the format of the data without our knowledge. We have the capability to open web pages as different file types, including text files, CSV documents, Excel workbooks, PDF files, JSON files, HTML pages, and XML tables. HTML stands for Hypertext Markup Language. It serves as the standard markup language for creating web pages. Tags that label pieces of content, such as headings and tables, represent the HTML elements. When we go to a web page, we do not see the HTML code, but rather the content rendered by this code. Let's see how the web code works for the NOAA Weather Service station list. We see that this file has a TXT extension on the end. If we right-click on the page and hit Inspect, it pulls up the code behind the website. We see the HTML code that renders the web page, even though the interface file appears in a .txt format. We can see where the data element tags go in this web page when we open up the body. If we connect to a web page not set up in a format that Power BI has the native capabilities to render, we may run into issues. The CDC web portal we looked at earlier also supports other files as well. Here we see the zip code to GeoID mapping in a CSV file format where we see commas separate the data fields. We can also look at the population by geocode we earlier downloaded. We will come back to this later when we set up an Excel workbook connection in Power BI. Let's go into Power BI and set up a web data connection. We can type in web, or we can go and look at other where the web option presents itself. Click on the web option. We see where we can put the URL of the web link to the data. We can copy and paste the NOAA station list into our Power BI file. We hit OK. Click Connect. Notice essentially that we see a data preview with the data in two columns set up by the fixed width delimiter set at position 41. We hit Transform Data to see what the data table looks like. We still see the commas separating the data fields. So what we need to do is go back into the source step by double-clicking on it to open up the gear wheel. Notice that the file opens up as a CSV document, so we change this to text file. Hit OK. We now see all the data in a single column. We can drag the arrows to expand the column to see all the data points. We will come back later to transform the data to separate it into separate columns. We're going to save this file as NOAA Station List and save it. There we have it. We've connected the NOAA Station List online to a Power BI file. We can also set up web connections to the U.S. Census Population Excel file we set up earlier by downloading the Excel file. In the U.S. Census Power BI file, hit Edit Queries, and we add a new source as a web connector. Let's first set up this mapping of the geocode by population. If we double-click on the All Geocodes link, it will download the data. However, we can also point it to the path for this file, and Power BI will open it up as a web connection. I'm going to copy this URL link and paste it into the URL, and then add the Excel extension on the end. And we hit OK and connect. 1 second, we need to go back in and add an S here. So we choose to reconnect again and add an S to the geocodes. Again, notice the navigator shows us 2 views to connect to. And this time, we're again going to select the second option, which will give us the table without the headers and the unnecessary rows on top. We hit OK. We now see this data connection loaded in the same way that we loaded an Excel file, except the connection is not to an Excel file in our desktop, but rather one online. Let's rename this GeoID to county and put a web at the end so we know that it's a web connection. We're going to use the web connection from here on out for this U.S. Census data. We also need to establish the connection to the zip code to GeoID mapping URL. Copy this web link and again go into the census file and select a web data connection again. Paste the link in and hit OK. We see that the Power Query Editor in Power BI has already picked up on the commas that separate the fields. We hit OK. And we're going to rename this query Population by Zip Code. And there we have it. We've set up 2 additional web connections in this particular U.S. Census file, which we will transform from here. API stands for Application Programming Interface. Web developers use it to connect their web applications to other web applications. An API connection works like a query where the original application sends out a unique query to the online data source, which returns a subset of the data we can use. The application we want to connect to must offer an API connection in order for us to query the data. An API key serves as a unique access key that allows us to create our own API queries. Safeguard your own API key and do not share it with others. We are going to set up an API connection to the U.S. Census data we saw earlier. When we look through the API documentation on the U.S. Census website, we see that we need to request an API key to query this connection. We will receive this API key in an email, which includes not only the API key, but also documentation for setting up the API query parameters and endpoints. We can set up API connections in many ways, which can sometimes make them confusing and tricky to set up, but do not let this deter you. We set up a URL query string for the U.S. Census API connection we saw earlier by breaking it down into separate components: the API endpoint, the query parameters, and our own API key. We pick back up with our U.S. Census Power BI file. To set up the API connection here, we create a new web connection and paste in the API query string into the URL box. We enter the entire URL with the API endpoint query parameters and key. We hit OK. We created the API connection successfully, but we need to convert these list links into a useful data table. We will do this using transformation steps. Rename this query U.S. Census API for county populations, and enter to keep the rename. We also need to save this file to make sure that we keep the updates, including the new API. Apply the changes later. You can find the end state of this file in the exercise file, but remember you will need to insert your own API key for this connection to work. The more complicated REST API data connection uses command requests, including the GET request, which asks the server to retrieve a response, and the POST request, which asks the server to create a new resource. To get our REST API query to work, we need to determine the resource endpoint, the query string parameters, and the headers. When we create a REST API connection, one of the formats that the data returns in is in a JSON format. JSON stands for JavaScript Object Notation. It transmits data objects as human-readable text with attribute value pairs and array data types. The data is set up in name value pairs, separated by commas, uses curly braces to hold objects, and square brackets to hold arrays. We are going to obtain weather info from the NOAA website using an API query. We start with its developer API documentation. We see here how the different query parameters and paths are configured. And if you're interested in learning more, you can check out the NOAA API documentation yourself as well. We first need to request an API token. And you can do so on the NOAA website by entering your email address. We are going to use the free Swagger Inspector online tool to test and develop our REST API connection. Based on the NOAA API documentation, we need to set up the query as a GET request. So we set the request to GET and the parameters of the Swagger Inspector, and we then paste the AP endpoint next to it. We then hit the send button to see what results are returned. We get a status of 400 bad requests, and it says token parameter is required. So this is where we need to pass and put our token in the GET request. In the Authentication and Headers tab, we can see that we have request headers boxes. We put token in the header box, and then in the value box, we put our own API token. We then hit send again. We see the query ran successfully because we see a response returned in the JSON format below. And we also see a status of 200 OK, meaning that the query ran. We can now add another query parameter to the endpoint. So we just type data to the end of it and send the request again. We receive an error message that we need to add parameters such as start date to the query. This means we need to add the query parameters that we saw in our NOAA API documentation. We go back to the parameters page, and we're going to first add the dataset ID. And the dataset ID for the daily summary of weather is GHCND. We then need to add the start date. And the start date, note that it is a query string with no spaces in between it, and also all of the letters are in lowercase. We go over to the value box, and we first put the year, and then the start of the year, 01/01 for January 1st. And notice that this is set up as a string parameter in a text format, which is unusual and not the typical date formatting that we would see in other data science applications. But this is how the query is set up, and this is how we need to input the parameters. You can also add the end date, which we're going to say 2019/12/31. We add another new parameter, this time for the Santa Barbara station ID. So we put station ID, and the Santa Barbara station ID is GHCND. We also need to add one more parameter, and that is we need to add a limit of 1,000 because otherwise the query defaults to returning 25 records, which is not going to cover even a month of data. It's only going to cover the 25, so we need to expand it to 1,000. So we put limit of 1,000 in here just because that's the highest limit, and if we want to add, say, other stations later, we've already defaulted it to the highest limit. We send this API request again. And this time we see our desired data set returned in a JSON format. Now we go into Power BI again. We are going to add our NOAA API query to the NOAA station list we set up earlier. We go to New Source, Web Connection. So here we have a few options we can leverage for the web connection. We can choose advanced options, which will give us a space to enter the header for the token. And we can also separate the URL string into several different parts. For the sake of the example being easier to set up, I'm going to just paste the entire string we put together with the Swagger Inspector. But if you want to break it apart to test it out yourself, you can as well. Power BI has the capabilities to leverage API connections, but if you're doing a lot of API connections, it might be better to look to other API flow sources or ways to organize and query the data. So we're select Advanced, and we first put in the query parameters that we set up in the Swagger Inspector. So here we can just paste the entire URL string. We copy and then we go over to Power BI and paste it in the URL parts. We then need to add the HTTP request header parameters down at the bottom. We put token in the first box. We can then paste the token into the header parameters, and we say OK. We've already passed our parameters in. We know that this query works. We don't need to use or choose from any of these other access options. We hit connect. We now see the connection works, but instead of a data table, we see a table with hyperlinks to list and record. These are Power BI objects, and we will talk more about these later in this course. Let's rename this query NOAA API Connection. We can also click on the source step to make sure that the web connection reads the data in a JSON format. So we double click on the source step, and we see that we use open file as a JSON. We can also see that we can no longer see our token field in the web connection. And the reason for this is privacy concerns. However, we will see later that we can see the token in the M code. Be careful with your API token and key because it can be seen in other parts of the query. We confirm that works. There we have it. We've established a connection to the NOAA API query, and we are going to revisit this step later when we learn more about objects and transformations. OData stands for Open Data Protocol. They allow for an easy way to connect to online data without having to manually build REST API connections. We can learn more about OData connections and how to create them from their website we see here on the screen. For this example, we are going to use an already existing OData connection for the CDC weekly flu mortality numbers in the form of a URL link. On the CDC website we see here, we can see the options for viewing the data, visualizing data, exporting, and using an API key. If we click on these three dots at the end and choose Access Data via OData, we see a dialog box pop open on the screen. We copy this OData endpoint. In Power BI, we choose a new source to connect to. We choose the OData feed. We then paste in the URL we copied from the CDC website and hit OK. Click Connect again on the next screen. We see the data connection established, but I would recommend inspecting it. I know for a fact that this CDC OData connection sometimes does not contain the most recent numbers or matching totals between the state, regional, and national levels. But we can see the connection works. We hit OK. Rename this query by double-clicking on it, CDC flu numbers OData. We save the Power BI file to keep the updates. Choose to apply the changes later for now. There we have it. We have now connected to APIs in 3 different ways in the past 3 videos. We can use Python code as its own data connection in Power BI. The Python script must produce a result in a data frame output. I would recommend running the script first in a compiler like Spider or Anaconda to troubleshoot any potential issues. To download Python, first go to the Python website and download the latest version of Python we see on the screen. Once downloaded, run the Python executable. Click on Install Now. We see now that the setup was successful. Close out of this window. Now open up Command Prompt. Let's check to see if Python is installed. Type Python space -- version. Okay, we see we have the most recent version. We need to make sure the pip command line tool is installed so we can run the modules such as pandas in our Python script. To do this, go ahead and close out of the current command prompt. Open up the installer again by going to our Downloads folder, select Modify, click on Next. Now, on the Advanced options, click to make sure that Python is added to the environmental variables. We click on that to get the checkbox. Now hit Install. We see the Modify was successful. Close out of this window and go back into the command prompt. Check to see if pip is installed. We type in pip space -- version. Great, we see we have pip installed. Now we can use pip to install pandas by typing in pip install pandas. We see that since we already have pandas installed, we don't see the pandas loading. However, on your machine, you will see pandas downloaded and loaded to your command prompt. We are now going to install matplotlib by typing in pip install matplotlib. Again, we already have this on our machine, but your machine will go through the process of getting it. Great, we've now installed the Python packages we need, and we can start using Python in Power BI. In Power BI, we connect to a Python script by first selecting Get Data at the top. We can select More at the bottom, which will bring up a new screen. Now type in Python in the search bar and select Python script. We see at the bottom, this is where Python is installed. However, if you need to change the settings on your computer to get Python to run, let's click out of this menu and point to a different folder. On the File, select Options and Settings, Options, choose the Python Scripting tab, click the drop-down menu, and select Other, where you can point your Python home directory somewhere else. I'm going to cancel that because mine is already fine. I'm going to select to get data again. Again, search for the Python script. Select the Python script again. Here I paste in a Python script that uses Panda and NumPy to produce a data frame output. It doesn't do much, as you will see, but it shows how a Python script would work in Power BI. We click OK. We now click on our data frame output, and we see the data frame that the Python script produces. Click on Transform Data, and we see the data frame again in the Power Query editor. Finally, let's just save this file, apply the changes later. We'll save this Power BI file as Python script example. Hit save. There we have it. We see how Python scripts work in Power BI. We define metadata as information about a value associated with a value, or simply data about data. Every value has a metadata record. Metadata provides useful information for web data, such as updated date. If a function uses this value, when it constructs a new value, it does not preserve the old metadata records. In Power BI, let's look at our NOAA data connections. The NOAA API connection we set up earlier, which returns the results as a list and the metadata as a record. We duplicate this query by right-clicking and selecting Duplicate and name it NOAA API Metadata. If we click on the metadata records hyperlink, it takes us to see the metadata details where we see the record again linked to the results set. If we click on this records hyperlink, we see key information or metadata about our API connection, such as the query returns 853 results, with a limit of 1,000 records. Also, notice at the top the formula bar points to the metadata results of the result set. And there we have it. We can see an example of metadata in Power BI. Using the right data type in Power BI determines our success in setting up calculations. We commonly use the number data type, which includes decimal numbers, fixed decimal numbers, and whole numbers. We have several date data types such as date time, time zone, and duration. We can run into issues with date data types if the reference field is not an actual date, or if the date comes from a different locale, such as Europe, which uses the day, month, year format rather than the US month, day, year format. Text data types include text values, but we can also set up numeric IDs as text data types. For example, we can make numeric US zip codes a text value because we would like to retain their leading zeros. Other less frequently used data types include true, false, or Boolean values, and binary, which are typically file types. If we go into the US Census Power BI file we set up earlier, for the population by zip code query, we see the query editor automatically adds query steps in the Applied Steps section to promote the headers and change the data type. Notice that it changes the zip code to a number instead of a text value, and as a result, we lose the leading zeros. We can remove the entire query editor step to change the data types, but this removes all the updated data types from the other data table fields. So instead, we select to change the zip code ZCTA to a text value. We want to replace this as a current step rather than adding a new one. The rationale for this is because if we convert this numeric value into a text value, it's already lost its leading zeros. We select Replace Current, and there we see that the leading zeros now apply to the zip codes. We can also change the GeoID value to a text value because these also need to preserve the leading zeros. We can see from this menu at the bottom, the Use Locale selection will allow us to change the date, for example, into a European date format. On the GeoID, let's replace the numeric value with this text value. Click Replace Current, and we've updated this field as well. There we have it. We can see how we can easily change the data types in Power BI to enable ourselves to do calculations and other transformations later. We have already extracted data, and in looking into the metadata as well as changing the data types, we started the transformation step of the ETL process. To make a useful data table, we can undertake helpful initial transformation steps for columns, such as promoting the first row as headers for the column names, renaming columns, removing unneeded columns, moving columns around, or duplicating them. In the US Census Power BI file we set up connections to earlier, we see in the query for the population by zip code where we selected the source, then promoted the headers, and changed the data types. If we click on the source step, we see where the headers are in row 1 instead of the header row. We then see that the headers are promoted in the second step. We can easily move the columns around in the Power BI data table. Let's say we want to put this CPOP, which represents the population for the entire county, right next to the population for the zip code. To do so, we can grab onto the column header and move it over so that it's right next to the population by zip code. We can insert the step here because it's not going to cause the query to break. Select Insert. In this data set, we really only need the columns for the zip code, the GeoID, the population for the zip code, and the population for the county. To highlight all 4 of these columns, click on the column headers and hold down the Control key to highlight multiple columns. We then right-click on these column headers and select remove other columns. We now have 4 columns remaining in the dataset. Let's rename these columns. Let's call the first one zip code. We'll keep the GeoID in the second column the same. We'll call this population by zip code. And we'll call this last column population by county. If we go into the change type step, we see that we run into a problem. And the reason is because we are changing the data type of a column that we have renamed. Because we only have 4 columns remaining in the data table, let's just go ahead and remove the final step here where we change the data type and instead change the data types here ourselves. Let's change the population by zip code to a whole number and the population by county to a whole number as well. We see how the initial field transformations pare down the data set to get rid of unneeded columns and to also make it a bit cleaner and easier to read. Let's save this file to keep our updates for the U.S. Census. We'll apply these later. Let's see what impact these initial column transformations have on viewing the native query. Let's go back into our Power BI file for the CDC flu data and select the ILI net, which is going to show our SQL query. Let's see what impact moving columns around has on viewing the native query. Let's just move the region to after the year. Now let's see if we can still view the native query. We can. We go into it. We see that the column order may have changed in Power BI, but we still see it in the same position in the query. This is because the order that we pull the columns in a SQL query does not really matter. If we rename a column, let's see what type of impact it has. Let's rename this region. And right-click on Rename Columns and view the native query. We see that it has added a new piece of code to view the native query, that it renames the region column into a proper capitalization. And we're going to save our changes and we're going to revisit this query folding as we examine other transformation processes. We can split a field into 2 or more fields based on a selected delimiter, number of characters, or position. Here we see that we separate the full U.S. zip code that includes both the 5-digit zip code and the 4-digit delivery code within the zip code into 2 separate fields. We use the dash as the delimiter or separator to split the 2 fields on. In the Power BI NOAA Station List file, go to the query for the stations. Let's rename this query NOAA Stations. We first need to remove the change type step because we don't have a column to reference. We can see that we have a step level error message. It says column 2 of the table was not found. Remember that Power BI initially separated the query into 2 columns. We changed the query so that column 2 does not exist anymore. We can click on the little X to remove the change type step. We now have all our data in a single column. To split column 1 into separate columns, select it, go to Split Column on the Home tab, and select by the number of positions. We choose 12 characters because we can see that these station IDs have around 12 characters in them. We split once as far left as possible to pair off the station ID. If we use the repeated function, we would end up with it being split into columns of 12 characters repeatedly. And we can see that, especially when we look at the station name, 12 characters is not going to contain all the information we want. Click OK. We now have 2 columns where the column names use a 1 or 2 after them to reflect their column 1 origins. We can repeat this process to split up the remaining columns by their character positions, or we can perform this process much more efficiently by splitting all the columns at once. We remove the change type step and also remove the split column by position. Now we go into split column again and choose by positions. The query uses AI to determine estimated splitting positions, and we see when we confirm that it does a pretty good job. From here, we can rename the first column Station ID, and we can also call column 1-5 the station name. The other fields we see here give latitude, longitude, and other geographic information. And there we have it. We can see how we can easily use the column splitting functionality to make a single column into an actual useful data table. Merging columns works the opposite way of splitting them. It takes two or more columns and combines them into a single field in a functionality similar to concatenation. We see here, we take a 5-digit zip code and combine it with the 4-digit delivery code for the zip code into a final zip code. It uses a dash to separate the fields. In order for the merge functionality to work, the merge fields must have the same data type. In our U.S. Census Power BI file, we go to the GeoID to county mapping, the web connection, to show how the merging functionality works. We want to combine the state code and the county code into a single field called GeoID. First, we need to make sure that both these data types are set to the same for both the fields. They're currently both numbers. We want to actually use text data types instead to preserve the leading zeros. We go ahead and select text and replace the current step. So we've updated the state code to include the leading zeros. We do the same for the county code. Again, select text and replace the current step. Now we can combine these two fields into a merged field. Select both of them. Now right-click and select Merge Columns from the drop-down list. We are going to call this new field GeoID, and we're not going to use the separator between them, meaning that we will see it all as a 5-digit text field. Click OK. And we see that not only have we created a GeoID field, but we also no longer see our separate state and county fields. In the NOAA Station Lists Power BI file we set up earlier, we already split the data into separate columns and renamed some of them. Now we can go into the columns and make changes to make them cleaner and also used in later transformations. In Station ID, when we click into a value in the column, we see that there are spaces after the station ID. This is because when we split the positions by a fixed number of spaces, it leaves extra spaces between the fields rather than trimming it to the exact length. Selecting the Station ID column, we right-click, go down to the Transform function, where we can see that we can trim, clean, capitalize each word. We have a number of options to transform this column. For the text field, when we select Clean, it removes any non-printing characters. Let's go ahead and do that to make sure we don't have any in the Station ID field. Now let's remove the trailing spaces by again right-clicking on the Station ID column name, selecting Transform again, and choosing to trim. We see the applied step for trimming the text. Now let's go back into the same value, and we see that we have eliminated the trailing spaces. Now let's go into the station name, and we're going to remove the trailing or leading spaces for this column as well. And we're also going to capitalize each letter. Right now we see everything in capital letters, and capitalizing each word makes it a bit easier to read. Again, we right-click on the column name, transform, and select to capitalize each word. There we have it, some simple text transformation steps that can work wonders for our data and help make the table easier to read and work better in transformation and other steps later. In our CDC flu data, we have the total number of flu mortality deaths by week, where we see the year and the week indicating the time frame. First of all, when we look at the CSV file, we first need to remove the top row, select Remove Rows, remove the top rows, and we remove one row at the top. Now we can promote the headers so that we have column names. On the Home tab, go to Use First Row as Headers. I think it would be really helpful to add an index column. We see that the order of the year and the week show that it goes in chronological order, beginning with 2016, week 40. To do this, we can add a column and select to add an index column, which we see defaults to start at 0. We can also start it at 1, but let's start it at 0 because that's the first week. From here, we can use numerical transformations to change the index column. To see what the options are, right-click on Index and show the transform options. Remember that with the text value, we saw trim, we saw clean, but now, because it's a number value, we see numeric transformations. We see rounds, absolute value, factorial, logs, powers, fractional powers, and then we also see the text transformation function if we want to use it. We can also leverage calculations in the Add Column menu. Let's go to Standard and select Multiply. I'm going to multiply by 7 so that we take the weeks out, which is given by the index, and multiply it by 7 to give us the days out. Select 7 and hit OK. Now we see we created a new column which gives us the number of days from the start. I'm going to rename this Days into Measurement. And there we have it. We can see the numeric transformation options available in Power BI. In the manual sample of data we entered in Power BI earlier, we saw dashes in place of zeros for some of the data, which is not uncommon to see in many reports. If we go to this data set and convert amounts from text number type to whole number, we see that now we have an error hyperlink in place of the dash. This means that Power BI does not pick up on a dash as a number type. To handle these errors, we can select to remove them. To do this, right-click on the header and select Remove Errors. We now see a reduced data sample size because we have removed the months that have dashes in them or the months that have 0 amounts. What we're doing effectively here is filtering out the dashes. But what if we want to include them? There are a few options we can explore for this. Let's remove the last step where we removed the errors. And now let's explore another option where we replace these errors with 0. We hit OK. And now we see a data set updated that includes the zeros, so we do not lose that granularity in our data. And we know that for these 3 months with 0 amounts, we're in fact picking up the 0 in the calculations. We can also change the dash into a 0 to start with. To do so, let's remove the Replace Errors step and also remove the Change Type step. Now we can right-click, Replace Values, select the dash, and replace it with the 0. The reason we would do this instead of, say, replacing the errors or removing them is that we may end up with a value where it's not just a dash, but another number or text value that is not a dash, and we're converting all the errors, which may or may not be dashes. By replacing only the dash values, we can isolate these to make sure that we are indeed replacing them with 0. We click OK, and then we can update the data type to whole number. And there we have it. We can see a few methods to deal with error messages and what is often similar to the Excel if error message and how to handle that in Power BI. In the U.S. Census Power BI file, we look at the GeoID to county web query, where we want to focus on the state and county details pertaining to each GeoID. Filtering, we can remove or keep rows based on whether or not it meets our set criteria or conditions. Filtering works similarly to removing rows, but we may find it easier when working with ranges or several conditions. We see the summary level column on the very far left-hand side of the table. 10 pertains to the United States, so it's a country level. 40 pertains to Alabama, a state, and 50 pertains to the counties within the state. If we click on the summary level dropdown, we see when we click Load More, we can see more of the filtering options. We only want to keep 40 and 50, so we want to remove 10, 61, 162, and 170. We can do that by unselecting Select All and select 40 and 50. Now we see we have a reduced size data table that contains only the states and counties for the GeoID to county mapping. Next, let's see how to remove duplicates. Let's duplicate the GeoID to web query. We right-click and select Duplicate. I'm going to rename this query GeoID to County Testing. Notice that the summary level shows multiple instances of 40 and 50. If we click to remove duplicates on the summary level, will it only remove duplicates on the particular field? Will it only leave 40 and 50 left with multiple values? Or will it simply act on this single field? We right-click on summary level and select Remove Duplicates. And we see that it only focuses on that one particular column. So now we're only left with two values, 40 and 50. But what if we include GeoID? Does that change the functionality of removing duplicates? Let's remove the last step, remove duplicates, by clicking on the X. Now let's select both summary level and GeoID, right-click, and select to remove duplicates. We see now that the Remove Duplicates feature works on both columns rather than one. So if we want to remove duplicates from an entire table, we would have to select the entire table for it to work. We earlier set up a connection to a SQL server for the CDC flu data to test out how database connections work in Power BI. We discussed how Power BI gives us the capability to use query folding to optimize performance for database connections. Let's rename this query SQL Server Connection. We right-click and select Rename and hit Enter to save it. Next, let's see if we move a column, what the impact on the query folding will be. We already know from right-clicking on the navigation step that we can view the native query, and we see it looks like a SQL query. Now let's make more adjustments to this data table and see what the impact on query folding is. Click on Total Patients, click on this column, right-click, and select Moved to the Beginning. Whether or not we want to leave it here is not particularly relevant, but let's see if we can still view the native query after performing this operation. We right-click on Reorder, and we see that yes, we still can view the native query. I'm going to remove this step because I don't particularly think it's going to be important later. Next, let's remove all the columns except for year, week, which we select by holding down Control and selecting on the week column, ILI total, and total patients. Right-click, and we select Remove Other Columns. Now, if we right-click this step in the applied steps, we see that, yes, we can still view the native query. Now, let's rename these columns to make it easier to read. Rename year so it uses lower cases, and same with week. ILI total, we're going to rename this total cases, and we're going to use lowercase for total patients as well. Now, if we right-click on the step, we see we can still view the native query. Next, let's merge two columns together and see if we can still use query folding. Click on Year, Control, and then click on Week. Right-click and select Merge Columns. Let's use the dashes separator. And we'll rename this Date. We right-click on the Merge Column step. We see that now the View Native query is grayed out, meaning that merging columns does break the query folding capabilities. And I can also tell you that splitting the columns breaks the native query folding as well. Let's exit out so we get rid of this step. And next thing, what we're going to do is we're going to replace the week 41 by right-clicking on it and replacing values. We're going to replace 41 with value of 60. You hit OK, and then right-click on the step. We see that replacing a value also breaks the query folding capabilities. So we just remove this step. Now let's filter out so we just have 2019 data. Select 2019 and hit OK. We have a much shorter list because we are only looking at 2019 data. Now let's remove duplicates for the week just to see how it works. Right-click and select Remove Duplicates. Right-click on this step, we see that now we can no longer view the native query. So we click out of this step, and let's see what the native query looks like now. We select View Native Query, and what we see here is that at the beginning, we saw all the columns selected, and we didn't see any filters. Now what we see is we see filters, we see the renaming of the columns, and it looks very much like SQL code. So this is how query folding takes a database connection and through our commands pushes SQL code back to the database. Therefore, we don't have to perform SQL code or write SQL code in order to leverage the capabilities of the database. We define a programming object as a particular instance of a class with a combination of variables, functions, and data structures. In Power BI, Power Query Editor objects include tables, lists, records, values, binaries, functions, errors, and parameters. We rarely use binaries, functions, lists, and records by themselves, but instead combined with other objects like table objects. In the U.S. Census Power BI file we set up earlier, let's go back to the Excel connection in the web, and let's go to the Query Editor source step. When we set up this connection, remember that we selected for Power BI to drill automatically into this third table here. It drills into the table, and it used this as our query. We click on the navigation step. We can see that it's selected that item as the table object that we wanted to drill into. Let's go back to the source step, and we're going to duplicate this query, and I'm going to rename it GeoID to County Testing with Objects. Now we go back again to the source step. Let's hover over this last item in the table. What this functions as is a navigation table, essentially. It allows us to select the table objects from within the file. We see here that the navigation step will provide us the name of the item and then the type of programming or the Power BI object that it is. Now, if we hover over this last item, table object that we select to use in the query, we see that we can preview it by clicking on it so we don't enter into it so that the hyperlink doesn't actually drill into it, but we can see this allows us to preview the table object. Conversely, we also can drill down into it by selecting the actual table. Let's just go ahead and create a new navigation step because we already duplicated this query. Now we only see that selected table that we drilled into in the data table. The query only shows a single table object. And this is the query that we selected. Let's try something else out really quickly. Let's remove the change type, promote headers, and navigation, which takes us back to the original source step. Notice that in this data column, we see 3 table objects. We click on the diverging arrows at the top, and let's uncheck Use Original Column Name as Prefix, and select OK to see what happens. What we see here is an expanded data table built from combining the table objects and all 3 of them that we saw in the source step. In the name field, let's click on Load More. We see all 3 of those tables listed in this data table. This is a pretty neat feature, being able to easily combine table objects. However, I would recommend exercising caution when combining data tables and these table objects, even from within the same query or multiple files within a source, because we don't know if the columns line up. We need to know what is in the tables beforehand. So combining them can do some really impressive calculations and transformations later, but we need to know our data before we proceed any farther. We will find using these table objects immensely useful for many types of queries in Power BI. If we think of table objects as objects with rows and columns, we can visualize list objects as a single column in a table. Lists do not have a data type, nor do they have an explicit column name except the name of the list. If we visualize lists as columns in a table, then record objects are its row counterpart. Like table objects, we can drill into and expand list and record objects in queries. In the Power BI file NOAA Station List, let's select the NOAA API connection. Remember that the NOAA API connection returns the results for the API query in a list object. We know that because we see here in this little table, we have a list hyperlink that we can click on. To drill down into it, we simply click on the list object. We can also tell this is a list object because we see the list icon next to the query name. If we click on one of these record hyperlinks, let's see where it takes us. We drill into the record object for an individual data point for the daily weather summary. While it may be nice to know this information, we want to have the entire data set and not a single record or a single row within this list. We click on X to remove the last step we did. We again can expand the list object. This time, let's convert this entire list to a table. We can highlight the list, then at the top for the list tools, we see a new transform section, select to table. We see here that we can now enter a delimiter and select how to handle errors. We're just going to select not to use a delimiter for now and select OK. While this table object looks very similar to our original list object, it is now in fact a table object, as we see with the table icon next to the query. And we can expand out all the records into a combined data table. We select the diverging arrows at the top. Let's unselect Use Original Column Name as Prefix. We hit OK. We see an expanded data table that includes all the data in the NOAA API query we set up. The API query we set up for the U.S. Census data returns the request as a list object of list objects. We can convert this list object into a table object by selecting to table from the list tools transform functions. Again, we are not going to use a delimiter, and we'll figure out errors if we run into them. We see more list objects contained within the original list object. Let's choose to expand out this column. Let's say expand to new rows. We now see all the data for this U.S. Census API connection in a single column. While this may make it easy to view, and we know that we can see all the data in a single column, it's not particularly useful for data analysis because we don't want the state region and all the other field headers to be in the same column. We want to have a data table with multiple columns. I'm going to save this query by renaming it and saying single column. And we'll come back to this later. And then I'm going to duplicate this and rename this query multiple columns. I'm going to delete the last step where we expanded the entire table into a single column. So now we're back at the table object that contains many list objects. Now let's click on the diverging arrows again and select Extract Values. This allows us to extract the items from each list object across a row of the data table rather than in a column. We're going to select a delimiter to use. This will allow us to separate the fields in the list. I'm going to use 3 upright bars as a custom delimiter because I know that that is rarely seen in many data sources. Select OK. We expand this out, and we can see the field names in row 1, followed by each of the values for the fields in the rows below. So although they're combined into a single column, we know that this is pretty easy to split the columns by a delimiter because we put the delimiter in ourselves. So we highlight the column again and select to split by delimiter. And we use the 3 upright bars again and select each occurrence of the delimiter. Click OK. Where we see now we have a data table with multiple columns in the columns we want them to be. We can then use the first row as headers. If we look through and see if we have anything else we want to change. So there we have it. This is how we can use record and list objects to transform queries. And it's pretty neat to see how their functionalities work and how we can use them for really interesting query transformations. We define binary objects as files combined or read using other functions. In the NOAA CSV folder Power BI connection we set up earlier, we see the content column contains hyperlinked binary objects in each row. If we click on one of the binary hyperlinks, this takes us into a view of a single data table from one CSV file in the folder. Let's get rid of those last steps. We start again with the source step. To combine all these binary objects, click on the button with 2 downward arrows next to the column header. We click OK. We now see all the files combined into a single data table. We also see another folder and several other Power BI objects in the folder as well. We will revisit and discuss these more later. If we go into our NOAA Excel folder connection, we can see that we also have access to these 2 downward arrows to connect the 2 binary objects, which are Excel files. Let's click on it and see what it does. What we see here are the Los Angeles and Santa Barbara table objects within the Excel file for 2018. However, we're missing the 2019 data. So using this button is not going to work to combine Excel files. Let's go into the PDF file. We put the PDF file in a folder, and then we connect it to the folder. This is a single PDF file, and the binary object, let's see what that looks like. So we've drilled into the binary object in the NOAA PDF folder. Now we see all the tables in the PDF as table objects in the query editor. we click on one of these, we can preview it. We can see what it looks like. It's got the headers, and then we actually have our data down here. We can use these two diverging arrows to combine all the table objects into a single data table. Uncheck Use Original Column Name as Prefix and click OK. Now we see a table object that we combined through expanding the data tables to include the table objects within the query. From here, we can promote the headers so that we actually have the proper information in place. I scroll down, and this is going to take a bit of work. And then we can look at other connections. Out of curiosity, if we go back into the No Excel file and we click on the binary object, this takes us to the same view that we saw earlier when we tried to combine the files. We see the two table objects within a single Excel file. We're going to revisit later how to connect to the Excel folder so it includes both files. But for now, it's pretty neat that we can combine the PDFs using binary objects and table objects. Grouping allows us to aggregate a field based on another selected field. Here we see we choose to aggregate the total field based on the group field. The aggregation we see here is the sum function. Grouping increases calculation options and improves query performance, but it also eliminates more granular data analysis because it removes much of the row-level details. In the U.S. Census Power BI file, let's duplicate the query population by zip code. We rename it by adding the suffix grouping to the end of the query. Now in this new query, select the zip code column by highlighting it. In the Transform tab, we select Group By all the way on the left-hand side. We select Group by Zip Code. We're going to call this new column Max Population. And it's going to return the maximum population for each zip code. We can also access advanced grouping options by selecting the Advanced Radio button. This allows us to add more dimensions and more values to the grouping if we choose to. We're just going to stick with the grouping we set up and hit OK. What the grouping functionality does is for each of the zip codes, it returns the maximum population of an affiliated county. We will revisit this more later and do some interesting transformation steps on it, so stay tuned. On the screen here, we see the data on the left and the grouping of that data on the top right. In the grouping, the sales across all years for a particular group are reported. Notice the pivot table on the bottom right is a bit different. Here we add the years in a separate columns at the top of the table, which adds a new dimension to the way we aggregate the data. The data reported are all the same, just in a different manner, and it's a lot easier to read than the original chart. In the NOAA Station List Power BI file, we go to the NOAA API connection. Notice that in the data table, we have 5 columns. The second column is labeled as data type, but what it really is categories of weather such as precipitation and temperature ranges. We would like to put these categories as separate columns at the top. To do so, we first select this categories column called data type, which, yes, is a bit confusing with our previous discussions. We select the column, we go to Transform, and we select the pivot column function in that ribbon. We select to use the values as the values we want to pivot on. We then can choose from the advanced options to not aggregate the data. The reason I'm choosing not to aggregate the data is because if we do have duplicates, that's another concern, and we want to see the shape of the data table with the columns on top. We don't necessarily want to sum up or try and figure out how to aggregate the data. We select OK. Now, each of the categories has its own field, but we notice the precipitation column shows values 100 times higher than their actual amounts because the API query does not include the decimal place. To change the precipitation into actual inches rather than one without a decimal place, we're going to divide this entire column by 100. We saw this earlier with the numeric column transformations. We select the precipitation column, go to the transformation tab, and this time select the standard, divide, and we select to divide the entire precipitation column by 100. Now we have an updated precipitation number, which is in inches. So pretty cool. We can see how a combination of the pivot functionality and also transforming a data column can make a big difference to the way that we see a data table. Remember in the U.S. Census Power BI file, we set up a U.S. Census API connection where we later transformed it into a single column of data. Although we ultimately found a more effective method using another functionality, what if we had instead the only option of receiving the data this way? We can use the pivot functionality to change the shape of the data table. This column is technically a text data type, and we cannot directly pivot a text column. If we look at how the pattern of data appears in the table, notice that the date labels appear every 8 rows, so we would need to create a table with 8 columns when we pivot the table. We first add the index column using 1 as the start value for the first row. We select Add Column, add index column from 1. Next, we create a modulo column that references this index column using mod 8 to segment the rows into columns that repeat 1 to 8 over down the entire column. To do so, we select Standard and Modulo, and we put 8 in as the value we want to use and hit OK. We see that the modulo column starts at 1 and goes to 0 at the final value of the data set. However, I'm just going to use this as start the index at 0, which will make it a little easier to read. We start at 0 instead. And then we see that the modulo goes from 0 to 7 for what we know to be the column labels in the first 8 rows of the data table. We need to make the modulo into a text value, which will allow us to pivot this data set. The last thing we need to do is take the index column, use the integer divide functionality so that we see rows 1 through 8 with row 0, and then the next 8 rows as 1, and then we can pivot the data set. So let's go ahead and do that. We select the column, we go to Standard, Calculations, select Integer Divide, and again we put 8 in as the value. We are going to leave this column as a whole number data type, which allows us to pivot this table. I'm going to delete the index column because we're not going to use this. We're going to see how the pivot functionality works with these 3 columns. We select the modulo column. We select from the Transform tab to pivot the column. And we use the initial column 1 as the values column. And we select to not aggregate the values. We hit OK. And now what we see is a new data table where the integer division that we saw before we pivoted the column is the row number, and the 8 columns we see after that are the columns of the data table. So we can quickly do some transformation steps to make this a bit more readable. We can remove the integer division column because we don't need it anymore. And we can also promote the first row as headers, so it should have column labels. And there we go, a workaround for pivoting an otherwise slightly unruly data set. Think of each cell in a table as a value with pivot coordinates referencing row and column dimensions. When we transpose a table, we change the data table shape, but not its pivot coordinates, as the rows become columns and the columns become rows. Let's use the NOAA PDF Power BI file connection we created earlier to connect to a PDF file. We can use this data table, the one query in it, to test out how the transpose functionality works. The PDF file we see here in the data table contains several unneeded columns, and we may find it faster to filter these out by transposing the tables. Notice that we do not see the first row in the headers right now, so let's just transpose it in its current configuration. To do so, we make sure we have the query selected, go to the Transform tab, and we select Transpose. The first row in the fourth column used to be the fourth row in the first column. Let's delete the flag column by filtering out the row to remove the flag value. And we can also remove the first two columns and the last column in this newly transposed data table. Now we transpose this table back by hitting the Transform Transpose functionality again. We promote the first row as headers. Now let's transpose the table again and see what the results look like. Again, go to the Transform tab and select the Transpose function. Notice that we no longer see the headers in the table. So if we decide we want to use the headers in the table, make sure that you don't put them in the header position first. Do that as the last step in your transpose transformation process. When we create a pivot table from the original data table, notice that we see aggregated sums based on the rows and columns in the table. Unpivoting puts the column headers in their own row, but notice it does not technically reverse the pivot functionality to the original data table because we cannot reverse aggregation when we unpivot a data table. In the NOAA Station List Power BI file, we go to the NOAA API connection query we pivoted earlier and then performed a numerical transformation on the precipitation field. We can now use the unpivot functionality because we did not select the aggregation when we originally pivoted the data table. In order to unpivot these column categories, we can select the category columns, and we hold down the Shift key to highlight all four of them, and we right-click and select Unpivot Columns. Notice, if we go back to the previous step and we right-click, we see that there are three options for unpivoting columns. We can also only select the date, station, and attributes fields and then unpivot the other columns. We would unpivot in this manner if we had changing category names, but we knew the other dimensions, the date, the station, and the attribute, would stay the same. Thinking of it this way prevents the query from erroring out because we reference other columns to pivot from instead of the potentially dynamically changing column rows. And there we have it, a few options to explore if we want to unpivot columns. In the CDC Flu Data Power BI file, we go to the SQL Server connection query. When we performed cleaning transformation steps on this database connection, we know that filtering a column still allowed the query to work because we could translate it to a SQL command that Power BI could send back to the database. Let's remove the step where we filtered for only the year 2019, so we can test out how integration transformation steps affect query folding. We can see in the last step by right-clicking on the Renamed Columns step that we can still view the native query. Let's take a look at the initial query we will start with. We see it looks a lot like SQL code. So we're going to add some of the integration steps we just learned to see how this affects the query folding and these SQL commands we see on the screen. Now let's pivot the table so that we can see the trends of the total cases across years by the same week. We first remove the total patients column. Then we select the year column because we want to use these as the individual column headers. We go to the Transform tab and select Pivot Column. For the Values column, we use the total cases that we want to aggregate for each week for all those years. We choose the total cases as the Values column we want to use. We click on the Advanced options. Let's set this to Don't Aggregate. We can hit OK. We now see the pivoting functionality performed on the data table. If we right-click on the pivoted column step, we see that the View Native query is grayed out, indicating that pivoting columns does break the query folding capabilities. Let's get rid of this step and try this using Group By clicking on the X next to the step name. If we group the table so we can get an average number of cases per week across the total of the 4 years, let's see what impact this has on query folding. Let's select the week and select Group By. We're going to call this new column Average Cases, where we average the total cases across the 4 years. Hit OK. We now see our new table where we use the Group By functionality. If we right-click on the Grouped Rows step, we see that we can view the native query, which means that query folding is working. This makes sense because Group By is a frequently used SQL command. Lastly, let's see if performing a sorting functionality on the week column by sorting from A to Z impacts the query folding. We click on this arrow for filtering. We say Sort Ascending. We see the Sorted Rows step now appears in the Applied steps. We right-click on this, we can see that we can view the native query. And this also makes sense because Order By is another frequently used SQL command. Notice that the week uses a text value, and when we put it in the sorting order, it sorts by alphabetical character effectively instead of number. So when we change the data type, let's see if this impacts the query folding. We select whole number, and we click on the Change Type step. We see it's grayed out, meaning that it actually breaks the query folding. Let's delete this last step of changing the type, and we will right-click on the sorted rows to view the native query. When we open up the native query, we can see the Group By SQL command and the Order By SQL command. So it's pretty neat how we can leverage query folding to effectively write SQL codes and commands without having to do them ourselves. Power Query Editor formulas share similarities with their Excel counterparts with a few key differences. Excel formulas are not case-sensitive, while Power Query formulas are. Excel counts using base 1, while Power Query counts using base 0. And Excel type conversions are implicit, while Power Query observes strict data typing. Analogous formulas between Excel and Power Query include the formulas we see on the screen. Because Power Query does not implicitly convert data types, we need to either first convert the fields to text data types or set up a text conversion function within the formula, such as the example formulas we see here. Let's go back to the NOAA Station List Power BI file and the NOAA Stations query we set up. We know that if the station ID starts with US, it is in the United States. Let's set up a custom column to get the first 2 characters in the station ID using the text.start function. We select the Add Column tab and select Custom Column. We're going to call this new column named Country. And we say text.start. Click on the station ID, or we can alternatively, if we start typing in station ID, you can see that there is now a smart prompt available in the query editor that we can just use our arrows to go down and hit enter to select that particular field or the function. Comma, and then let's use 2 for the first 2 characters in the station ID. Close the parentheses to close the expression. And notice that we add 2 to the end of this expression, which is the same as what we'd see in Excel. Let's hit OK and see if we get the same result. Okay, so we see the first 2 characters in the station ID column. Now, if we were to change this formula, and we can go back into it by double-clicking on the step. If we were to change this to text.start, where neither the text nor the start part of the function were capitalized, would the formula still work? Let's hit OK. And we can see that data typing is significant and an important part of using the Power Query Editor in Power BI because it is capitalization sensitive. So let's correct this error by just going back into the formula and adjusting it again. Also notice that unlike the splitting functionality that we could also use to separate the first 2 characters in the station ID field, creating a custom column preserves the original field. We don't lose the original column when we perform this function on it. So let's talk about what we refer to as the difference between the 0 and the 1 counting. We're going to test this out by creating another custom column and calling this the length of the country ID, which we already know is 2. We'll call this length testing. So text.length, again, we know to capitalize this. And scroll down, we know that we need to use the country. Close the brackets and hit OK. So length returns a length of 2. So this means that the base of the counting is not referring to the length of the characters, but instead is referring to another way that the counting works in the Power Query Editor. So we'll create another column and test this out another way. We'll call this position testing. And what we'll say is text.position, which determines if the US is in the country, it will return the position, and otherwise it will return another amount, which we're going to see. We type in the country field, and we type in US, and we put the text expression in quotes so that it knows that it is a text expression being passed into the formula. And we hit OK. And we had a -1 here because there is not a match between the US and the country field that we see here. This is not the US. However, if we scroll down, load more, and let's see, if we select 0, aha, these are the US countries. What this means is that when we look at the country field, the US starts at position 0 rather than position 1 that it would in Excel. Now let's revisit our NOAA PDF Power BI file. We only have one connection in this query, but we want to use a text formula on some of the fields in this table. Click on this applied steps. We're going to start the promote header step. So let's remove the steps that are after it. Delete and delete. So now what we see is we see the year, the month, and the day as column headers in the file. We want to combine these 3 fields into a date field. So to do so, one way we can try this out is by first changing the year, month, and the day to whole numbers. And then we'll create a new column to combine them together. Custom column. We're going to call date. And we're going to use the US formatting for dates. Start with the month and separate these using a / and an ampersand between the fields and the text characters and so on. So you add the day and we add the year. So we should see all of these fields concatenated into a single field. However, they all error out. And the reason for that is because we are combining a text field in the form of the / with a number field in the form of the year, month, and the day fields. So in order to do this, we can do two things. We can change the data types for these three columns. But if we need to use these again in other calculations, we have to worry about what effect that will have on those other calculations or the transformation steps. So instead, I'm just going to change the formula so that it converts these numeric fields into text values. And we do that using the text.from function, and we put the parentheses around those numeric expressions. We can actually make this easier to read by putting these on separate lines because it will not impact the actual formula. And we'll put this one line. Now we can see it all in one view. And we see that the red squiggly line, much like a Microsoft Word error, indicates that we have a spelling issue, or in this case, a syntax issue. So we use the close parentheses and hit OK. So there we have it. We can see how we can use text conversion function to convert numeric values into text values that we can then use in other formulas, which is pretty impactful and allows us to do a lot of different calculations. The enrichment part of the transformation step includes creating formulas, such as conditional formulas. The high-level logic of a conditional formula says that if condition 1 is met, then we return this result. Otherwise, if condition 2 is met, then we return another result, and so on. And if none of the above conditions are met, then we return this alternative result. We write out conditional formulas in Power BI using the syntax we see here on the screen. We need to keep in mind a few key points when setting up conditional functions, such as if, then, else if, and else all need to be in lowercase. And because we already know Power Query formulas in Power BI are case sensitive, the function will not work otherwise. We start the first conditional expression with if. The other alternative conditions after that use the else if syntax, and we can repeat else if as many times as we need to. The then expression returns the result for each line, including the last alternative result, if none of the conditions before hold true. In the U.S. Census Power BI file, we go to the query for GeoID to county mapping web connection, where we see the GeoID details for the state and county levels. Notice that the state of Alabama has a summary level of 40, while the counties that follow directly after it have a summary level of 50. Let's create a conditional column that says if the summary level equals 40, then we return the area name because that shows the state. Otherwise, we return null. We go to Add Column. And we can select a custom column. I'm going to call this State. And we will say if summary level equals 40, then we return the area name, else we return null. And we'll see why null is important in another video where we talk about the transformation steps from there. Now we see that because we have summary level of 40, we have the state name, and the counties underneath it will use Alabama as the state name as well. If we double-click on the added column step name, we see that it actually uses the conditional column functionality from the Add Column tab. This makes it easier to write out formulas, but it also limits the flexibility for creating complex conditional formulas. And there we have it. Pretty simple and pretty powerful example of a conditional formula. Returning to the U.S. Census Power BI file and the GeoID to county web query, we put the state name in a separate column by leveraging a conditional formula. The area name shows the state name followed by the counties within it. If we scroll down the list, we see the state name as null until we get to the state of Alaska. What we want to see in this table is the county name with the state of Alabama in the field next to it. In order to do this, we are going to leverage the fill down functionality. An important thing to note about using fill up or fill down is that in order for the fields to be filled, they need to have null values in these fields. It won't work with other values such as blank. We select the state name, we right-click, go to the Fill menu, and select Down. So now we see Autauga County, Alabama. Scroll down till we get to Haynesboro, Alaska, for example. So the last thing we need to do is, because we don't want to have Alabama, Alabama, because Alabama is not a county, we can scroll over and remove the 40-level summary from the data table. Lastly, we can just rename this area name county to make it easier to read. There we have it. We see how the fill up or fill down functionality can help get our data table looking the way we want it to be. In the CDC Flu Data Power BI file, we select the query for the CSV file, which is the same as the SQL Server connection, which we will visit later when we examine enrichment steps for native queries. Having dates that correspond to the flu mortality numbers in a continuous standardized date formula will enable time series later in dashboards. In order to create a date field, we need to look at the year field and the week field. We first convert the year field into a date. However, instead of seeing that it's the first day of 2016, we instead see the 7th of July, 1905. And the reason for this is because we're converting a whole number into a date rather than replacing the existing step. The way around this would be if we remove the change type 2 step and go back into the original change type step 1. Then we click on the whole number data type and change it to date. Select Insert and replace the current step. Now we see that the year is January 1st of each respective year. To add the dates to this table, let's go to the last step for rename the columns. And then we go to Add Column and choose to add a custom column. We're going to call this new column name Dates. In the formula bar, we type in date dot add, and we can see that we have 5 different options for the time interval we want to add to the dates field. We're going to select Add Weeks because we have the weeks into the year. We see it here next to the year column. And we reference first the year, which is January 1st of each respective year. Then we add the number of weeks into the year by typing in week and hit Tab to pick up the number. Close this off. However, one issue we need to make sure that we're thinking about is whether or not the week starts at 1 or if it starts at 0. So let's click OK and go back in. We're going to just look and see what the ranges are. So it starts at week 1. This means that rather than having January 1st as week 1 of the year, we instead have the date a week later. To remedy this, we remove the filter step that popped up, and we subtract 1 from the week. We hit OK. And now we see that in this row, which is in the first week of the year, it starts at January 1st instead of January 8th. Also, if we want to take this year value and move it to the end of the year, which is saying these are the total flu cases in this entire calendar year, instead of the 1st of January, we want to use the 31st of December. We can do this by creating another custom date column. We're going to call this end of the year date. And then we'll see the formula pop up again as we type it out. And again, we see 5 different options for the ending of a time period. This time, we're going to choose end of the year. And we can reference the year field, which would be January 1st, Or we can reference the date field that we created that's continuous over each week of the year. So every 7 days, we have a new date. I'm going to just use the year and close off the parentheses. So now we'll take the January 1st date and move it to the last day of the year. And hit OK. And there we see we now have the last day of the year for each of our respective years over here. The last thing we want to do with dates is to look at the day of the week. January 1st occurs on a different day of the week each year, which has a small impact on the spacing between dates that we can account for. Let's create a date formula to determine the day of the week that January 1st is on. To do so, we go to Add Column, select a custom column. I'm going to name this column Day of the Week. And in the formula bar, I'm going to type in date.day. We can use day, day of the week, day of the year. Giving the day a number is not particularly helpful to us. So we're going to use the day of the week name. And again, refer to the year field and hit OK. And we can see that the January 1st of 2016 is on a Friday, while the next year, January 1st, is on a Sunday. And there we have it. With a few pretty straightforward date formulas, we created a continuous date field and some other helpful date functions that we can later use in Power BI dashboards. Remember, we define binary objects as files combined or read using other functions. Excel and PDF files, for example, typically contain multiple tabs or tables in them, or what Power BI knows as table objects. We previously drilled into single binary objects contained in a folder connection to see the table objects in them and combine them. However, if the folders contain many tabs or tables, we first need to read the file using a formula to extract the tables or tabs from within them. Then we can combine this into a single data set. We previously set up a connection to a folder of NOAA CSV files, and when we combined them, we lost the file and path details. Let's try to combine the CSV files using another methodology, which includes a formula. We first duplicate our NOAA CSV query. I'm going to rename this with formula on the end. We are now going to read the CSV files instead of combining them by creating a custom column. To start with, we select the Invoke Custom function, right-click, and delete all the steps until the end. Now we add another column to read the CSV file. I'm going to call this column CSV Tables, and to read the file's CSV document, and reference the Content column, which contains the binary objects. Hit OK. We see that this column returns a table object for each row in this new column, which we can then expand into a combined data table. From here, we can remove any columns we do not need by Control-selecting the columns we want to keep. I hold down Shift, keep those tables, the folder path, and the file name. Right-click, remove other columns. We can then promote the header, first row as headers. And one more step we need to take to at least make this data set look presentable is we remove the duplicated column headers that are now in the combined data table. So this is going to select the Tmax attributes because there's not a lot of value options in here, and select to not keep it. And there we have it. We can combine the CSV files using a formula instead of selecting to combine them in the interface. In the NOAA Excel and PDF folder Power BI file, let's revisit the connection to the Excel folder. Duplicate this query and rename it with formulas on the end. Now, we need to create a formula in this table that allows us to read the tabs in the Excel workbook. To do so, we're going to remove the last steps in the query editor, which we use to view a single Excel file. We then select Add Column, Custom Column. I'm going to call this Excel Tabs. And I'm going to use the function excel.workbook to read the files in the content column. Select OK. So we have a new column consisting of table objects that we can then expand out. And this allows us to see the tabs within all the Excel files in the folder. We can then combine all the table objects from these tabs into a single data set by selecting the diverging arrows in the data column. And from there, we can promote the headers, remove unneeded rows, and filter out the duplicated column names as we saw in the CSV folder connection earlier. Now let's examine the PDF folder connection again. I added another PDF file to this folder by duplicating the existing PDF file so that we would have more than one file in the folder that we could work with. I'm going to duplicate the NOAA PDF query and again rename it with formulas on the end. And in applied steps, I'm going to remove all the steps other than the source step. I also need to rename the folder path, and we'll talk more about this formula bar and what I'm doing later, to 0605. So now we see two PDF files in this folder when we refresh the query. To combine these files, rather to combine the tables in both these PDF files, again, I'm going to add a column, and this time I'm going to use a function specific to reading the tables in a PDF file. I'm going to call this tables and PDF.tables. And again, this function is going to reference the content column. I hit OK. So let's hit the diverging arrows to expand these two table objects out. What we see now is all the tables within the PDF file. So to expand the data from all the tables, again, we click on the diverging arrows in the data column. So now there we have it, a combined data set of all the tables in multiple PDF files. From there, we can remove that needed column, promote the headers, or filter out any duplicated names for the column headers in the fields. Now we know how to use formulas to read the tables in files and combine them into useful data sets. In the CDC Flu Data Power BI file, we go to the SQL Server connection query to test out the impact of enrichment steps in the transformation step have on query folding. As a reminder, query folding allows Power BI to translate our transformation steps into SQL code to send back to the database, thus improving performance. We are going to take the query we've used for previous query folding and remove some of the later steps. We can view the native query in this renamed column step by right-clicking on the step name and selecting the view query because it is available and it's not grayed out. We see the native query dialog box shows us transformation steps in the form of SQL commands. Now let's add a column to this table and see what the impact to query folding creating formulas has. I'm going to create a new column called Flu Incidence Rate. To get the flu incidence rate, I'm going to assume that we can do this by dividing the total cases by the total patients. We see the new column added to the data table. We also see that we can still view the native query. Now let's add a conditional column. I'm going to call this season. Just as a way to test this out, the week equals 40. Then I'm going to say it's winter. Otherwise, it is summer. And hit OK. we right-click on this Add Conditional Column step, we see that the View Native Query option is still available. Now let's add a date function that we previously learned about earlier in this chapter. I'm going to call this date, and I'm going to use the date function to add the number of weeks to the year. And add the week. Hit OK. All right, we can see that not only does this error out because we are creating a date function using a text value for the week and a text value for the year, but it also causes a strange issue with the flu incidence rate, and we cannot view the native query for this data table anymore. Let's click on the X to get rid of that last column. Now let's right-click again on the conditional column and view the native query. And what we see looks a lot like SQL code. We see that for the conditional statement, it uses the SQL case commands. And when we created the new field for the incidence rate, and it only divides the total cases by the total patients, but it also converts the numbers, which were originally text values in the data table, into number values to calculate that number. So there we have it. We can see how query folding works for these enrichment steps and how we can add formulas and still have access to the query folding. We record our extraction and transformation steps in Power BI using an array of function options. We see the types of functions available in the Power Query M guide available on the Microsoft website we see here, which can be a helpful reference. We can encounter two types of query editor errors. Row-level errors occur as individual hyperlink row errors in a data table. Examples include representing zeros as dashes, which do not directly convert to numeric values. Step-level errors occur when the query editor step cannot return the intended result for the entire function performed, or even the entire query. Examples include dividing a column of text values by a number. In the U.S. Census Power BI file, we look at the GeoID to county web query. When we click on a step in the query, over here in the applied steps, we see the function for that step in the formula bar at the top. The query editor applied steps record the extraction and transformation functions and their order performed within a query. For adding a column, we see the function we wrote out to add the column, and we also see the table function add column. This is what we will see later as the M code for that applied step. We can physically move the order of the applied query editor steps by right-clicking on the applied step and selecting to move it to another position in the order of applied query editor steps. In this version of Power BI, we cannot drag them into another step order in the list. We need to be cognizant of potential issues that occur when we move the steps around because order matters. For example, if we move the merged column step up one by right-clicking and selecting Move Up, we see that the Change Type step below it now errors out. This case is an example of a step-level error. Think of each of these steps in the Applied Steps list as performing an extraction or transformation step on the output of the previously applied step in the list. If we do run into these issues, either move the step back to its original position or determine where the step errors out and delete that step and perhaps those thereafter. To correct our query, I'm simply going to move the merge column step down one back to where it came from. So again, we right-click and select Move Down. We now see that we don't run into any other step errors anymore. If we open up the Advanced Error at the top of the Home tab, we can see the query editor steps as lines of M code that record these functions and steps in the query. We can copy this code and paste it into an entirely new query or file, and it will work the same way as long as we bring over any other queries referenced in this code. Microsoft develops the M formula language specifically for working in Power Query, although it shows similarities to the F# language. It is a straightforward functional programming language that treats computation as mathematical function evaluations and avoids changing state and mutable data. Within a mashup query like M, we can have variables, expressions, and values. M follows a fairly straightforward yet strict syntax. The query starts with the let statement in line 1 and ends with the in statement in lines 5 and 6. Encapsulated between the let and the in expression, we see the step name set equal to the variables, expressions, and values constituting the ETL processes in lines 2, 3, and 4. Because the step order matters, many of the expressions that transform the query reference a previous query step, but cannot reference a future step. M separates applied steps by mandatory commas, but also optional line breaks that make it easier to read. The last line of code, or the step, will not have a comma after it as we see in line 4. By referencing the last step after the in statement, this last step is the output the query returns in line 6. M is case sensitive. We can write out variables as strings without quotations in lines 2 and 3, but if we want to name variables with spaces, we need to start off with the pound sign and then put the variable in quotations as we see in line 4. Column or field names do not need punctuation around them, regardless of whether or not they have spaces. Optimally, in creating custom code in M, we start with the existing query editor steps and then modify the code where needed. This saves time and avoids potential errors. In our U.S. Census Power BI file, let's add a new folder to the query editor. We right-click on the query editor panel and select New Group. We're going to call this Custom M Code Examples. Hit OK. We see that the other queries, or the ones that were previously there, now exist in their own folder. We duplicate the query population by zip code, right-click and select Duplicate. We can then move this query into the custom code examples. We can right-click on it and select Custom M Code Examples. I'm going to rename this Example 1. First, let's go into the M code of this query by selecting the Advanced Editor. Let's first add some spaces to this code. We can add comments to programming code to document what a step does. To add comments in M, we use // and I'm going to just write a note under this source step that says obtained data source online. And we hit done. We see that adding this additional comments has not affected the code because we still return the same query. I go back into the Advanced Editor window. I'm going to move this to the end of the code for a source. Typically, the query editor uses the performed function to automatically assign names to the steps. This includes changing types or promoting headers, and if there's more than one changed type in this code, it will add a 1 to the end of this expression. I'm going to delete that. We can actually change these steps to be whatever names we want them to be. Let's change the M code to kind of have a bit of fun with it. Here, I'm going to say, let's start learning Power BI is fun. In this step, because Power BI is 2 words, I need to keep this pound sign and the quotations around Power BI. So we hit done. we see we run into an error issue. We actually need to go back into the advanced editor and update the M code. We need to update the steps in the function expression so they properly reference our new steps. Go back into the advanced editor. Each expression in our example query references the previous applied step in the M code. This means that it took the output returned from the applied step and applies it to the next extraction or transformation step. We know that the source step was the original step in the query, so we need to update the source step to let's, and we go down the list and update these steps. Now let's see if it returns the code. We hit done again. We need to make sure on the last step that we change this change type to fun because we're returning the last applied step in the M code. The fun step is the output we want to return. We click done again. We see we have kind of a fun expression and the applied steps now. And this query works the same way. We've just changed the step name. In the US Census Power BI file, let's duplicate the query population by zip code, rename it with example 2 at the end, and we want to move this entire query into the folder for custom code examples. We right-click on the query name, select Move to Group, Custom M Code Examples. Click on this code to select it. In the Advanced Editor window, we see the M code. Let's maximize the size of the screen on the top right. In our query, the first term of each applied step expression references the previous step applied in the query editor. Think of it as taking the output of the last applied step and adding another transformation function to it, for example. We can set up the steps in a single line of code if we would like by putting the steps inside of one another. This means we can consolidate the code by taking the expression from the previous step and placing it into the current applied step where we see that step name referenced. So here we take the renamed columns, we're going to copy the expression for it and put it as the first term in the change type expression. We can then delete the renamed column step. Then, if we go up to the removed other column step, we can take its expression and again put it inside the applied step below that. We're going to continue this until we have all the lines of code inside one another. We now see all our M code in a single line of code. Well, this makes the steps shorter. It also makes the functionalities much more difficult to read. But it's good to know that the step is an option. We hit done, and we now see we just have one applied step, and that's the change type step, which was the name of the one step that we now have in the advanced editor. We can add the data type as custom M code to the end of the function when adding a new column to a table, which translates to one fewer step in the query editor. On the screen, we see the functions for adding whole numbers, decimal numbers, dates, and text data types to the end of a new column function, which differs from converting data types in a separate step. In the US Census Power BI file, we duplicate the query for GeoID to County Web. We add example 3 to the end of the query and right-click and move to group Custom M Code Examples. We click on this query to select it. If we go over to the state column we created using a conditional function, we can change this into a text data type by clicking on the icon at the top and selecting text. We've changed the data type, but we also added a new applied step to our query editor. Instead of putting the data type changes in this separate step, we can add a data type inside another previous function, such as adding a column. When we select the Add Column step, we see the function used to create this conditional column. We then fill down to put the state name in each empty cell of this column. To change the M code, we go into the Advanced Editor window. In the M code, we locate the line for adding a column to the data table. We add a comma to the end of the expression, then type in text.type, which, as we mentioned earlier, is different from the expression used when converting data types that we would see here in this last step for changing the data type. We click Done. We go to this Added Custom step again. We now see that we have a text data type for this new column. This also updates as we look at the applied steps after adding the column. We can then delete this last change type step. There we have it, how to use custom M code inside an already existing query editor step. Binary functions allow us to read binary numbers and translate them into usable data. We can obtain NOAA data for an entire year through the zipped files on their website in the FTP section. In the website, we scroll down to the bottom of the list and select the data for the most recent year to download. Click on it so it downloads to your desktop. You can access these files in your 0706 exercise files. We can see that the file extension is a .gz, a type of zipped file using the gzip compression utility, which we cannot typically open using native applications on our computers. In the NOAA Station Power BI file, we select to add a new data source. We choose the text connector initially, and we select all files and go to our most recent exercise files. We choose the 2019.csv.gz data file. We see the actual file name and the extension type, but we cannot directly access the data in the file. In the formula bar at the top of the screen, we see the source connection uses the function file.contents to point to the source file path. Instead of going into the Advanced Editor window and updating the custom M code, we can update the M code in the formula bar. To unpack and read a binary file, we put the binary.decompress function around our file.contents function. So now we reference the source path with the binary decompress function around that path. In the second term of this binary function, we need to add compression.gzip as the compression type to read the file. We hit enter. We now see a link to the CSV file where we would typically see a data table. We double-click on it, which opens it up. We now see our uncompressed data table, meaning that the query reads the decompressed binary zip file as a CSV document. We see the additional applied steps on the right for this process. Rename this query NOAA Zipped 2019. There we have it, a neat extraction technique to open up a zipped file directly in our Power Query editor in Power BI. We can define a parameter as a query object that returns a single self-contained value that minimizes reliance on outside files and we can potentially use in multiple other queries. In a new Power BI file, we are in the Power Query editor, where we now select Manage Parameters at the top and select New Parameter. Name this parameter Current Date and choose its date as the data type, From the drop-down list of suggested values, we see three options. We keep this as any value and enter the date for the current date into the box for the current value. I'm going to revert this back to any so that we can go ahead and enter the current date. We then select OK. We see loading the parameter creates a new query denoted with the parameter icon. We can change the parameter values by entering a new value into the field on the screen. Click on the Advanced Editor window, where we can see the parameter has its own M code and metadata. Go back to Manage Parameters to add more parameters. Again, we select New Parameter. This time, we're going to call this parameter Start Date. We select any as type so that we can enter the dates, any value, and then we use the current date and we add the start of the year around this value. So this gives us the value for the start of the year. Then go into the Manage Parameters and let's add a new parameter for the end date. In this, I'm going to just take the value we used to create the start date and put the end of the year instead of the start. We hit OK. Now we see three parameters loaded into the query list. Note that if you plan on loading to Power BI Pro, we cannot change the parameters once we publish the report. We can convert the parameters back to normal queries by right-clicking on the parameter name and selecting Convert to Query. We notice that the parameter changes to another type of query by the icon next to it. We save this file as mLanguage objects. There we have it. We see how we can create parameters, which we can then use in other Power BI functionalities. Remember that we can think of a list object as a single column within a table or table object. The M language directly supports objects such as tables, lists, records, functions, and parameters. Within the M language, we classify lists, records, and tables as structured values or ordered sequences of values. We do not typically load lists as data, but rather use them as intermediaries in developing other queries. We can create lists using functions that create original lists or that translate into list objects, as we can see here with the example functions on the screen. In our M language objects Power BI file, for the first method, we can create lists manually using formulas between curly brackets. Let's create an example list with both character and number items. We select New Source, select Blank Query, and we start by typing the formula 2, 5, A, and C. Notice that the characters need to have quotation marks around them. We hit Enter. We now see we've created a list as indicated with the icon next to the query. Let's rename this query comma-separated list. Next, let's create a contiguous numbers list. Again, we select a new source, blank query. We type in 1 for the starting value, ... indicating it's a contiguous list, and 365. Let's rename this query contiguous numbers list. We can see this forms a list that looks a lot like a table column, except we see list at the top and the list icon next to the query name. For the second method, we can create lists through mList functions that use input parameters. We create another blank query. This time we type in the function text.toList hello world and hit Enter. We can see that this takes each of the characters in the text string and puts them as a separate item in the list object. Let's rename this query Hello World List. Lastly, let's create a list object using a dates list function. We create another blank query, and we use the function list.dates, starting with the current date for today, date time dot date fixed local now. Notice that we put the date time date around the function to create the local time for today's date. What this does is it eliminates the time from the date time function. We put 10 in because we want to create a list with 10 dates, and then we add 1 and hit enter. We get an error message. This is because we need to update the third term, the interval, to reference the duration. So to do that, we use the duration function to return the day interval. So 1 day, 0, 0, 0, to indicate a single day, and hit enter again. Rename this dates list. There you have it. Now we know how to create lists in M manually, starting with blank queries. Continuing on from the previous video, there's a third method that allows us to create lists by referring to a column in a table either as the table name or the step name. Since this method does not directly reference a list in the expression, we do not immediately recognize it as a function to generate a list. In the M language objects Power BI file, we are now going to add the population by zip code query from the U.S. Census Power BI file so we can test out how to create list objects from an existing table. Copying over the query allows us to consolidate our test work in the M language into a single Power BI file. Here's the M code from the population by zip code query. I copy this M code, and in our current Power BI file, I select New Source, blank query. I leave the formula bar blank, and I select the Advanced Editor window, and I paste all of the M code into the text space. Hit Done, and I rename this query Population by Zip Code. First, I duplicate this query. I can right-click on the query name, or I can also just select the query, Control-Copy, Control-V. I'm going to rename this query List from Step. I right-click on the zip code column header, select Drill Down, and we now see a reference to the list of the column of data in the formula bar. Notice that this step references the change type as the table we are getting the list object from. The zip code is the column of the previous step. This gives us a shortcut to the M code to extract the column values in a list without necessarily using the interface commands, and this can be very useful later. Notice the original query has a little table icon next to it indicating that it is a table object. Now I'm going to create another blank query and type into the formula bar equals population by zip code, which references the table name. And I use the open brackets, and here I put the column name, which is zip code. Hit enter. We now see this column becomes a list object with the list icon. Let's rename this query list from table. There we have it. 2 ways to create a list object from an existing table. Like list objects, we can create record objects manually, but with a few key differences. We start by creating a new blank query with a single record. Again, we go to New Source, select Blank Query. In the formula bar, we type equals city equals Los Angeles. State equals California. Remember that we enclosed list objects in curly braces instead of these square brackets. Also notice that we have commas separating the field names, and we actually label the field name within the record. Hit enter. Let's rename this query records in M. If we add curly brackets around the outside of it, we now create a list containing the record object. Convert this to table. Hit OK. Expand out the table. So we have now a single record object. Now that we've converted it into a table, let's add 2 more records to make it a multidimensional table. To do this, I'm going to add another record to the list. This time city equals Santa Barbara and state equals California. Now enter again. We now know how to create a table of records directly in M. We can perform calculations on lists, including the count, minimum, maximum, average, and sum of the items in that list. Earlier, in the U.S. Census Power BI file, we grouped the population by zip code data to return the maximum population for each zip code. If we go into the code in M by selecting the Advanced Editor, we see how the query sets up the function so that for each zip code, it creates a list object containing the corresponding populations. It then uses the list max function to return the highest population from this list object. We go back to the query list and we'll duplicate the population by zip code with grouping. We'll rename it sum. Now in the grouping rows step, we can go into the advanced editor and see all the M code, or we could also go into this formula bar and change the max to sum and see what impact this has on the query. Now, instead of calculating the maximum population for the zip code, it's calculating the population for the sum of the populations by zip code. If you go into the advanced editor window, we see that the grouped rows easily reflects our changes. See the impact that list objects have on the grouping functionality now? So we have already been leveraging list objects, but Power BI is using them behind the scenes, and now we understand how. Date calendar tables are immensely useful in Power BI, and we can easily create them through custom M code. In the M language objects Power BI file, let's create a new list directly in the formula bar using a blank query. Let's put a date formula into the formula bar to the date time, date of the date time dot local fix now, and hit enter. We get an error message when we try to create this list. Therefore, in order for this query to work, we need to use a workaround. In the same formula bar, put equals 1 ... 100 and hit enter. This creates a new list of contiguous numbers from 1 to 100. We convert this to a table, choose to use no delimiters. We then change the data type to date. Let's rename this column dates and the query dates table. Now we need to make changes in the advanced editor window in the M code. Let's add a few extra rows in front of the source step. We set up the start date to equal date.start the year, And then again, I'm going to reference the current date. Obviously, yours is going to be different than mine. So what this function does, this piece gets us the current date, whatever date that might be for you. And then this gets us the date and time of the exact moment. We just want the date, and then we just want the start of the year. So that's why there we see 3 functions nested inside one another. We add the end date. To do so, just going to copy the start date and put in the line below and use the end of year. Now, one last thing we need to do is remember the 1 to 100 returns a numeric list from 1 to 100. So in order to put the start dates in, we need to put the number.from around this entire expression for the start date, and then do the same for the end date. And in the source step, we replace the 1 with the start date and the 100 with the end date. And we hit done. We just create a dynamic date table for the current year by leveraging the power of list objects in M. We want to create a new dates table, and in order to do so, we are going to use a few more helpful list functions. List.generate creates a new list using loop logic. List.sort puts a list in numerical order. And list.combine creates a new list from 2 or more lists. In the M-language objects Power BI file, we just created a dates table using list objects in the previous video. What if we want to create a date table that only includes the paycheck dates, which occur every 2 weeks on a Friday? We first create a new group called Dates Testing, which we are going to add these queries to. We first create a reference date using a blank query. I'm going to turn the text value into a date value using the date.from function. I know that August 23rd was Friday, and I hit enter. I'm going to rename this query reference date. Now we go into create another new source, and this time I'm going to use the list.generate function. Here we see that 0 is the starting value. We increase each item in the list by increments of 2 until we reach 10 when the loop stops. The underscore character serves as a variable in conjunction with each for the list function. We hit enter. Now we convert this to a table. Select to use no delimiters and change the data type to date. Okay, we know we can use the list.generate function to create a dates table. Remove the last 2 steps from the query, and we go back into the advanced editor. Just create a few lines to add some more code. I'm going to create a line called reference date, and we know we need to start the value in the list.generate function as an actual number. So I'm going to use the function number.from of the reference date, which is pointing to the reference date query. Next, I do a start date equals date.start of the year of the reference date again. And again, I need to put the number.from around this expression. And lastly, let's add an end date .from of the date end of the year of the reference date. And put commas after these 2 expressions. And let's just test this out by returning the end date in the query. So this means that rather than returning the last step, the source step, we're going to return the end date. Hit done. Okay, what we see is our end date as an actual number value rather than a date. In the advanced editor, We're going to start by creating a list that uses the reference date as the start date. We increment each item by 14, which is 2 weeks between them. And then we stop at the end of the year. It's the end date. And this time, let's return the source. And hit done. Now we see we have the list of the whole numbers that we can later convert to dates to get a dates list. We still need to make some more edits. I'm going to call this list 1, and I'm going to create a second list called list 2. And this time I'm going to also use the list generate function again. And this time we are going to decrease each value by -1 and start it at the beginning of the year. I'll call this the start date, and end it at the reference date. First of all, other thing we need to do is we need to remove the equal sign so that it does not include the reference date as we create the list. So we do not duplicate the reference date as a list item in either of these. I'm going to call this new list dates, and I'm going to say list.combine of list 1, list 2, and I'm going to return this new dates list. Hit done. We need to do for the list.combine is we put each of these lists within another set of list characters. And hit done again. Now we see we have the list of the whole numbers we can then convert into dates. We select to table again and convert to the date data type. One issue that we see here is we start at the reference date and go to the end of the year, and then start at the beginning of the year and go through to the end. So we need to make some more edits to this. We first need to change the order of this so that list 2 comes before list 1. Then do done. And we see that we now have a dates table with 14 days between each of the dates. Let's rename this column dates. And there we have it. We can see how we can create a list of paycheck dates using some functionalities in M. In the NOAA Station List Power BI file, let's go back to our original NOAA API connection, which extracted API data originally as a list object. The NOAA REST API query we set up returned the data in a JSON format as a list object, which had API query limitations of 1,000 records and 1 year of data. So what if we put several API queries into one Power BI query and join together the list objects? To do this, let's first duplicate the NOAA API connection. Let's duplicate this again, and I'm going to rename this NOAA API 2018, and the next one, NOAA API 2019. So then I'm going to remove all the steps after the navigation. So convert it to table, I right-click and say delete until the end, confirm, and I do the same for the 2019 data. Right-click, delete until the end. We see now that both the NOAA API connections for 2018 and 2019 are list objects. So to create a combined query, let's set up a blank query that will combine the two lists together. Set this up as list.combine. We use the open curly braces, and we're going to refer to the NOAA API 2018, comma, NOAA API 2019. Hit enter. I'm going to rename this Combined NOAA API 2018 and 2019. From there, we can just convert this into a table where we can extract the data, and this gives us the data set. However, it would be much more helpful if we could consolidate both of these queries into a single query. I'm going to combine the 2018 and 19 into a single query and eliminate the list objects we see above. I duplicate the query and rename it all dates. So now what I do is I'm going to again eliminate this so we're left with the list object. And instead of referencing these other list objects, I'm going to put the list objects inside this query. So I need to go first to 2018, and I'm going to copy the steps inside this query. Then go to our latest combined version. And I need to rename this source 1, results 1, source 1 to make sure that all these versions of source 1 refer to the 2018 numbers. I can then hit done. I then do the same for 2019, and I copy the steps and go into the combined query again. And I put the steps below. Instead of 1, I put a 2 suffix at the end of the source and result steps. Now, source is going to reference results 1 because that returns a list object, and results 2, which also returns a list object. So we'll click done. We see we've combined these lists together as a single list object. From there, I'm going to convert this to a table and expand out the record objects so we see our results. And just to confirm, when I select to scroll down, I want to make sure that I see the 2018 numbers in here. Looks like I need to actually update the 2018. Double check. We actually have the 2019 end date in here. So I update the start date and end date and hit done. And we do the same in our combined query. 2018 and 2018 and hit done again. And we confirm. Yeah, we see both 2018 and 2019 in a combined query. We can add more list objects to the query than these 2 list objects we see here. But this consolidates our queries so that we do not have to have many list objects and have to worry about combining in 2. Pretty cool stuff. Power BI allows us to create custom function using logic where we first need to name the function parameters. We then create an expression to calculate the result. So far in this course, we set up many different functions by leveraging existing M functions rather than creating custom functions. In the NOAA CSV folder Power BI file we created earlier, we see we have 2 queries in the other queries section. Let's delete the query with formula at the end so we don't get confused. The other queries folder contains the combined NOAA dataset. We're going to duplicate this so we can make changes to it. When we combine the CSV files into a single data folder, the query editor automatically creates a new separate folder called Helper Queries, with queries for a sample file parameter, a sample file, and a transformation function. Let's make modifications to the CSV query with 2 at the end of it. I'm going to rename this Custom. We see the applied steps on the right-hand side. We start with the source step. Power BI automatically filters the hidden files if there are any. It invokes the custom function, renames the columns, removes the other columns, expands the data table, and changes the type. All of this is done automatically. Let's remove all the steps from the rename column step and below. We select delete until end and select delete. This transform file function is a table object that the function returns. If we double-click on this step, we're given some information about the function. However, I actually find this step at the top to be more helpful. We see that we are passing our content field that contains the binary objects into the transform file function. If we look at the transform file function, we click on the advanced editor, hit OK to take a look at the M code. We see it's a function object where we pass the file into as parameter 1, and it reads the file as a CSV document, and then promotes the headers and returns the table object with the headers promoted. So, given the logic that we can consolidate the steps in M into a single step, let's copy the source step and place it inside the promoted header step. We delete the source step. We hit done, which updates the transform file function to have the code in a single line. However, let's go back into the code. What we're really doing here is creating a function in the same way that we created a function earlier in this course. Let's copy this code and put it in our combined data table. Let's delete this column. And now what we do is we add a custom column. I'm going to call this the reading table objects. I'm going to paste the code in here. However, parameter 1 is not a field in our data table that we're creating this column for. So instead, I'm going to pass in the content field and hit OK. So we see this function returns a table object in the same way that the transform file function returns a table object. Let's check that we're not referencing any other queries. If we try to delete this group, it won't let us because the Noah CSV query and the transform sample file are referencing this query group. So we can go into the other queries and delete this. Select delete. And we'll go and expand these table objects. Okay. Now let's see if we can delete the helper queries. I'm going to delete and delete this. And finally, delete the entire group. To transform this combined data table that comes from combining the table objects, we can simply do these very familiar applied steps, such as removing the columns. We can remove the folder path, for example. And here we see a combined data set where the function itself lives when we add the custom column, which makes it much easier to understand. It is easier to think about adding the custom column with these functions inside of one another that return a table object. But it is also harder to read, and that's why we may want to make it a custom function to make it easier to understand what's going on. Creating a new column that returns a table object, we can think of the function parameter as the binary object that is the file passed into the function, and the expression that calculates the result we return as a table object as the expression to calculate the result. We can then expand this into a combined data table, which is a much easier way to think of the custom functions. On the NOAA website, we already downloaded the zip files for the 2019 daily weather summaries. Now let's download the zip files for 2018 and 2017, and you can put these zip files along with the 2019 file in the same folder. You can access these files in your 0902 exercise files folder. In a new Power BI file, we are going to connect to a folder of zip files. We first set up the connection to the folder. And hit OK. We select to transform the data later. Next, we're going to copy over the connection to unzip a binary file that we created earlier in this course. The code for how to do that is located in your 0902 exercise files folder. Select to create another query. I'm going to choose blank query and copy over the code. Hit done. And I'm going to update the folder path to our current folder source. We can see that it unzips the data from a compressed file. I'm going to rename this query single zipped file. Now what I'm going to do is duplicate this query and turn it into a function object. Remember, we saw the function object in the previous video where we learned how a folder of CSV files uses a transformation function to convert the file into a table object with the headers promoted that we can then combine. We're going to create our own custom query to connect to a zip file. To set this up, I'm going to call this function unzipped and going to use x as the variable that we pass into it. And I'm going to delete this single file path and put an x in it to allow us to pass the file path into the source step. And then to change type, I need to put let around this expression and then put an in and unzipped to be the expression we want returned. Also going to indent this to make it a bit easier to read. And we see that essentially the function object is a single step returned to the bottom, and these are the steps that we perform on the variable passed into the expression. I hit done, and I'm going to rename this function testing. Next, I'm going to duplicate the connection to the folder of files and rename it function testing. At the end is the suffix. And now we can think of adding another column that we want to refer to this function object that's going to return the result. So we know that the single zipped, and we pass through the content. Hit OK. All right, we get an error for this. And the reason for this is because in order to pass in the file, we're not looking to pass in the binary file. So if we click on it, we cannot read it. So what we need to do is actually pass in the file path with the combination of the file name. To do so, I'm going to go back to the source step and select only the file path and the name and select remove other columns. Now I'm going to merge these fields into a single field by highlighting them both, right-clicking, selecting Merge Columns, insert the step, and I'm going to call this File Path and hit OK. Now I'm going to go into the function again, and this time we're just going to add it again to make it easier to read. And we add the column again, and this time we're going to pass the file path in as the X variable into the function. I'm going to rename this Data Tables and Single Zip File Function Testing and pass in the file path field. Hit OK. We can then expand out the table objects so that we have all 3 years, 2017, 2018, and 2019, in a single data set. We can also consolidate all the data into a single query. Let's first save this Power BI file so that we can delete the other steps and check that it works. Select Apply Later, and I'm going to save the files to our folder. This NOAA zipped files, separated steps. And you can find how to do this in separated steps in your own exercise files. Now, I'm going to take this query output, duplicate it, and then I'm going to go into the function object and copy the code. And I'm going to rename this Consolidated Queries. I'm going to go into the advanced editor to include the function object within this query. So give myself some space, and then I copy the query for the function into this code. I can remove the let from the beginning because this is not a standalone function. And I can also remove the in unzipped at the end. And I need to put a comma after the change type as the last step in the unzipped function. I'm going to rename this, rather than unzipped, function 1. And then where we refer to the file path later, and this is where we call the separate function query, I'm going to put function 1 in this path as well. This added custom function sends the file path, which is the combination of the folder path and the name of the file, into the function 1 expression as the X variable, where the function that we already set up when we connected to an unzipped binary file returns the results as a table object, which we can then expand into a combined data set. As we saw before with the CSV functions, having the steps separated out into 3 separate steps makes it much easier to read rather than having everything consolidated in this added column step. Let's make sure this works. Click Done, and we see that the consolidated queries all are in the same query now, and I'm going to remove the other queries by highlighting them and deleting them. Select Delete, and I'm going to save this file as NOAA zip files consolidated query. So now I can also remove the file path if I'd like, and we would need to rename the columns, but we can see how we would use the combination of folder files and functions to combine an otherwise difficult query into a single query. In the U.S. Census Power BI file, we earlier set up the grouping to return the highest county population for each zip code. The county information is contained in the GeoID, which gives us the corresponding state and county name for each ID. This type of functionality is helpful if we have addresses with zip codes but no county information, and we want to figure out what county to map a zip code to based on the county with the highest population. However, This grouping only returns the maximum population rather than the county or the GeoID associated with it. We can use custom M code instead to add matching GeoID to this grouping. Duplicate this zip code query and rename it with the suffix with M code at the end. We go into the advanced editor to view the M code. Now we need to update the grouping so that it includes the zip code column, but it also returns a new table object as part of this grouping, which we put in. We're going to call this new table object all data, each with the variable passed through it, type, table, and then we're again going to return the maximum population because we'll need that for our next step. We hit done. Now we see that the all data returns a table object for each zip code. I'm going to duplicate this query so we can take a look into the table object. I'm going to rename it M with table object view at the end. Now for zip code 00601, I'm going to click on the table hyperlink, and we see that looking into this table object for the GeoIDs and the corresponding populations for zip code 00601, we want to return the GeoID 72001 because that has the highest population of the zip code. Now we'll go back into the query we're working with, and we need to add another step. We're going to add a custom column and just call this custom with a value of 1, which is a dummy variable or dummy value that we're going to update in the M code. In M, we need to make this new column a custom function that works as an inline custom function that iterates through each table object that corresponds to a zip code and returns the GeoID with the highest population. We can think of X as the table object associated with each row of the zip codes, and we're going to pass it into this inline function. And in order to return only the GeoID with the highest population, we're going to use the table select rows, which is the function for filtering. And X again is the table object, and we're going to pass the all data, that column, into it and say each population by zip code. And we're going to set this equal to the max population in the table object. And hit done and see what this returns. Okay, need to make sure that got the functionality correctly set up. We need to update this so we have all data in capital letters. Hit OK. So what we have is we've created another table object, but this table object filters the all data table object to only return the highest population GeoID. So we can remove the other columns. We can remove all data and maximum population because we do not need them anymore. And I'm going to expand out the columns. I'm going to not include the zip code or the population by county because really we're only interested in returning the GeoID and the population by zip code. Hit OK. And there we have it. We can see how we can use inline custom functions to change the way that a data table looks and the results it returns. After performing the extraction and transformation steps on our data sources, we then load the data tables into Power BI. We can select if we want all or only the selected queries loaded. For example, if we created a list object as a query, we may want to leverage it to create other queries, but we do not want to load it. If we decide to load parameters, they will no longer be dynamic. If you would like to create DAX measures, I would recommend putting them in a separate table so they are easy to see and access their calculations. We define caching as a process where we hide something for future use, which in our case is data we are going to store in the memory. Caching causes latency issues, and large data tables with almost real-time requirements may not benefit from caching. We also do not need to refresh tables we do not cache, and by caching only what we need, we can reduce refresh times. Caching into memory through storage modes improves query performance and report interactivity. We can set the storage modes individually for each table in the model, which lets us control the caching of data in memory for reports and enables a single data set. At the time of this filming, Microsoft is further developing this functionality, so stay tuned. In the CDC Flu Data Power BI file, let's not load the OData connection, but still load the CSV and SQL Server connections. To not load the OData query, we select the query, then right-click on it, and deselect the check mark for Enable Load. We now see the query name in italic, and if we right-click again, we see the Enable Load checkbox is now no longer there. To load data into Power BI, click on Close and Apply at the top left. We now see two data tables loaded into Power BI. We see three tabs to view the data. The Report tab, which is what we see here, where we can create visuals and dashboards. The Data tab, which allows us to view and filter the data we just loaded. And the Report view, where we join the tables with a look very familiar to that of Microsoft Access. To view the storage modes, click on a table in the Model view and select the Advanced options at the bottom. The Storage Mode drop-down list allows us to select between Import Direct Query and Dual. This is a new functionality developed by Microsoft, so stay tuned to see what updates come next. We can go back and change the queries by hitting the Edit Queries button at the top, and these changes are easy to make. Most of the errors I ran into when loading data into Power BI come from incorrect data types. Fixing errors after loading can be a huge pain and slightly cumbersome, but recent Power BI updates and a bit of insight on your end can make this process much smoother. In the manual sample Power BI file, let's set the sample data table so it loads with errors so we can work through how to fix them. Earlier in the applied steps, we replaced the dash values with zeros. Let's click on the X next to this step name so that the change type step now gives us errors. One of the newer developments in Power BI is the colors below the column name, where we see a red line indicating errors in the data set. Our sample data set is small, so we can see the errors, but the likelihood you will not be able to see these row-level errors gets much higher when you're working with a much larger data set. Load this data by clicking on Close and Apply. The data loaded really quickly because it's a small data set, but we see an error message indicating there are 3 errors in a single query. We click on the View Errors hyperlink, and this takes us back into the query where we will walk through the process of correcting errors that will also work with much larger data sets. Notice there is a new folder in the query list specifically to address the errors. It also indicates which time Power BI encountered these errors. Click on this query, and we see the time period and the amounts fields in the original data set, but we also see the table filtered down to only the rows with the errors. Click on the error hyperlink to see what the message says. It indicates that it could not convert that row to a number because of the dash issue that we already knew about. Delete this step. Note the rows where the data issues occur, and go into the actual sample data set to make these corrections. Clicking on the step before we change type, we see that indeed these are dashes. So we go back to the change type step, and this time we're going to fix the issue by replacing the errors with zeros. We enter 0, we hit OK. Notice that we no longer see the red line under the amounts column name, and the query no longer shows any rows erroring out, so we can delete this entire error folder group. If we look at the query specific to the errors, we see we no longer have any rows with errors. We select the query folder name, right-click, and delete the group. We close and apply, and see that this time the data loads and we receive no error messages, so we're good to go. While Power BI allows us to easily refresh data and update connection options, we also need to exercise caution to avoid running into issues or errors. The query automatically adds new rows and columns to an existing data set when we refresh it. However, if we rename, delete, or change positions with the columns in the data source, this will error out the refreshing process. We refresh our CDC Flu Data Power BI desktop file manually by hitting the refresh button at the top. We see it updates both of the connections. Refreshing the data also updates the entire query for the ETL process, which includes any transformation steps that also got loaded. You can think of Power BI Desktop as a design application, while Power BI Cloud Services are more for the enterprise level and working across organizations. Here's an example of a Power BI Services account that we can load our Power BI Desktop file to. This is just a demo, so please follow along to learn how this process works. In our Power BI Desktop file, I'm going to set up this CDC Flu data file so it only includes the SQL Server connection. I select Edit Queries, and we can also refresh the data from the query editor by hitting this Refresh Preview, where we can select which tables to refresh in the connections. Again, to disable the load for a query, I right-click on the CSV file connection and deselect Enable Load. So now we see we're only going to load the SQL Server connection for the CDC Flu data. Hit Close and Apply. Now I'm going to create a matrix for the SQL Server data. Select the matrix table and add the week to the rows, the year to the columns so we can compare them year over year, and then the total cases as the values. The one other thing I'm going to do, and this is just an example, is update the week so that it is a numeric value, which will actually put it in order. Now, before we upload this file into the Cloud Services account, let's first save it, which will save both the new visual and also our data connections. We go to the Home button and we select the Publish button over here on the right. We select the workspace that we want to go into. I only have one workspace, but if you have several, you'll be able to select them from a list here. And confirm. We see we've successfully uploaded our Power BI desktop file to the cloud account. So we go into our cloud account. And here we see the data set. And let's go into the reports. And now we see our small visual table that we just quickly put together. In order to make sure that we have the latest updates to our data in SQL, we want to set up a refreshing schedule to get every week of the flu data as it gets updated. We go to the Datasets tab, and on the Actions button, we hit Schedule Refresh. Now, we first need to download the gateway connection. Your organization might set this up for you, but in our case, we're going to use a personal gateway connector. So select Install Now. Now that we've downloaded the connection, we go into the Downloads folder. We can double-click on the On-Premises Data Gateway file. Oh, we see that we already have the gateway installed on this computer. If you're installing this for the first time, you will get a message indicating that it has installed. So I'm going to go into my gateway connector and enter my email address to get it connected to my Power BI account. Select the account you want to use and then enter your password here to link it up to the Power BI account. We select Sign In for this year. We get a success message indicating the gateway is online and ready to be used. So we hit Close. Now we go back into our Power BI Cloud Services account and refresh the page. We see here that the status is confirmed for the SQL Server. Now the data source credentials, I need to go in and update this. And instead of basics, I'm going to use the Windows without impersonation. I typically find that selecting the Windows account solves a lot of issues I run into. So I select the Windows option. And now we can confirm that the data source credentials are properly set up. And lastly, go to the Scheduled Refresh tab. Turn the Scheduled Refresh on. I'm going to refresh this weekly, and I'm going to refresh it on Monday morning at 3 a.m. so someone can look at this report first thing when they get it on Monday morning. And we pick the time and the time zone when we want this refreshed, and we can also add additional days or update the times. I select Apply. There we have it. We've learned how to refresh not only a Power BI desktop file, but how to set up a refreshing schedule so that we automate the data updates and make the best use of the ETL processes we learned in this course. Those of you who identify as Excel Power users use formulas to create Excel tables that join data with other sources and lookup keys into a single consolidated data table. Power BI, however, performs better when we join related tables after loading in the model view when they still remain separate tables, as opposed to merging them together in a single query in the ETL process. We can think of the relationships between tables in two ways. The first is the relationship between data tables and lookup keys, which typically leverages a many-to-one relationship. The second way to think of the relationships between tables is with the many-to-many relationship. Think of this as blending or aggregating two data fields with a shared ID. But unlike the many-to-one relationship, the second table can have many instances of the ID in the same way that we see those ID occurrences in the first table. This is a new update to Power BI and a pretty exciting one. In the U.S. Census Power BI desktop file, delete all the queries except GeoID to county, web, and population by zip code. We can then remove the web suffix from the end of this query name, which makes it easier to read. In the GeoID to county query, let's remove all the columns except GeoID, county, and state. Highlight those three fields and select Remove Other Columns. One last thing we'd like to do, using the knowledge we know about M language, is to add a text data type to the state field. So we go into the Advanced Editor window and M code and put in text.type and hit done, where we now see that this simple step allowed us to update the type in this conditional column we created earlier. The population by zip code is the data table, and the GeoID to county is the lookup key, because we will not see duplicate GeoIDs in this data table, but we will see duplicates of the GeoID field in the population by zip code because it's a data table. Now we load both queries by hitting close and apply. And we see both data tables successfully load. So now we're going to connect them together. And we see that Power BI has used a bit of AI to set up the connection, or what it believes to be the connection. We can double click on this to confirm it's joining the population by zip code on the GeoID field to the GeoID and the GeoID to county lookup table. We use many to one and cross-filter direction of single right now. For the sake of making this easier to read, I always try to put the lookup key above the data tables. So if we have many lookup tables or lookup keys, we would have the data at the bottom and the lookup keys above that. And this makes it much easier to read and for others to go into your Power BI file and understand what's going on. So the data table has multiple instances of the GeoID, while the GeoID to county has unique values for each GeoID in the GeoID field. And going back into this connection, the both option enables bidirectional cross-filtering, which means that the filters flow both ways for the tables, and this gives us more control over applying filters to related tables. And we can think of this as a single data table that technically comes into view, similar to what we talked about earlier with flattening the view in Excel. This is allowing us to see both sides of the data set, so to speak. We hit OK. And if we want to delete the connection between them, we right-click and select Delete. I'm also going to add an exceptions table. I'm going to put this in manually by selecting Enter Data. And this is just a very simple example. And I'm going to call this exception table. And I'm going to put state, and I'm going to use Alaska and Alabama as the two states that we want to exclude from the data set. And the rationale behind using these exception tables is that it makes it much easier to manage and see what we want to exclude rather than having to manually filter them. And other people can also see how we're dealing and managing with those issues. So click Load and confirm that we have this joined on the state fields, and I'm again going to select the cross-filter direction as both. Now, to check how this works, I'm going to go into the report view and put the zip code as a table, and then I'm going to put the population by zip code and the population by county. And this is aggregate as a sum. And then I'm going to use the GeoID to county, and I'm going to pull in the county name and the state name as well. So we can see how joining those tables together allows us to create a single consolidated data set that's easy to understand the relationships between the tables. If we add the exceptions table, we want to select and put this in the filters. So here we see the filters listed here, and we can just take the state and say, if we put this as blank, will we be able to see? There we see that we no longer see Alabama and Alaska in this table when we put this by alphabetical order. which means the exception table allows us to easily filter out what we do not want to include in this table. Composite models allow for many-to-many relationships between tables, which removes previous requirements and workarounds, such as introducing new tables for the sole purpose of establishing relationships. Let's create two tables with multiple instances of the same dates in each table and show how the new many-to-many functionality allows us to join or blend these tables together. Let's select Enter Data, where we will create two small sample data sets to test this out with. Here is an Excel file called Sample Blending Data that I will copy and paste into Power BI. You can find these files in your 1005 exercise files folder. I first copy table 1 and put it into Power BI and label it as table 1. I'm just going to load both of the tables to see how this works because we are testing this out. And now I copy table 2 and paste it into Power BI and label it with the name table 2. Now we join the tables together on the dates field. Make sure that the date is selected as the joining field for both the tables, and we use the many-to-many cardinality, and we'll use both as the cross-filter direction. We receive this yellow error message warning us of potentially duplicated fields and essentially telling us proceed with caution. We recognize that we want to blend these tables together, so we hit OK. Then we go into the report view, and I'm going to quickly create a table that shows the date field and the corresponding amounts for both the data tables. So there we have it. The composite model blended data together in a single table and allows us to use Power BI more efficiently.